Theinternational Engineering Students Conference 4.0. We have a huge schedule for you. But first and foremost, I'd like to go through some procedures and some steps. Yeah? First and foremost, when you enter the auditorium, please understand that we have to switch off our phones. Yeah?
Good morning. My name is Hattie. I'm a student of systems engineering. And today we're going to sing a song which is called Summertime. Summertime.
And right about now, I think we will start us off with some words of respect to our Almighty. So I will right about now invite Anna to give us some words of prayer. If that's okay. Anna, would you please join me on stage? Alright, so we may rise even as we say the words of prayer.
It's in Arabic to consist of praising God and asking for guidance. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين
I have to say my special appreciation to Chairman ISC, Quincy and the team for making this happen. We will be launching our innovation and project week, where we'll have competition from students. I want to urge all the students here, I want us to start thinking, since the best way to predict the future is to create it now. Let us create our future now by thinking of the projects. During this pandemic, we've really had very many challenges, and this pandemic is here to stay. The secret of change is to focus on all your energy, not on fighting the all, but building on the need. We know Corona is here, so let's not focus on fighting it, but let us find a way of building on the need and see on how best we can achieve that. So I want to welcome everyone on today's session. Feel welcome, feel free. I just have one parting shot. And if you're an engineer, you need to think on it. And my parting shot is, when the winds of change blow, some people build the walls and others build windmills. What will you build? And on that note, I want to welcome Engineer Kikwai, the Owner Secretary General. Thank you.
Good morning. My name is Nathan Kiplamat. I'm the UNSA Secretary General, University of Nairobi. And being the senior most administrator here, I'll take this opportunity to welcome you all to the University of Nairobi. Guests, feel at home. Welcome, interact with the students. We as the University of Nairobi, we are committed to scholar excellence, and that's our aim. So today, I just want to congratulate the ESA team for organizing such a fantastic event. Since I was in first year, I've never got a chance to attend this forum, but today I'm privileged and I want to learn. There is always a saying that if you are young and talented, you can move the world. And I want to tell you engineers that being here is a great indication that you want to change the world. And you are young, and that's a great thing. So be proud of that and do the most of it. Make the most out of it. And we have a very welcoming Vice Chancellor. This event was supposed to be cancelled due to COVID, but he said let it proceed. Can we appreciate his efforts? Also, on behalf of the UNSA Council, I want to inform you that we will be having some events targeting the engineering students. We will be having the real estate fair. We will also be having the engineering conference. And I'm challenged by the work done by ESA. We have a lot of funds in our kitty, but we have never done such a thing. It's always politics, day in, day out. But I'm challenged. We are going to do something for the engineering school. We are going to change the narrative. So, I don't have much to say, but to say the event is on, and welcome all. Thank you.
She's put up an event like this before, and when we put up one like this, it's because we are looking up to what she's done before, and we're thinking, how can we improve it? What can we do better? So right about now, I'd like to call up Miss Grace Kanyi to talk to us. Grace Kanyi, please join us.
Oh, such a big introduction. And then you find a small person, right? I don't think I'm that small though. Welcome everyone. It's so amazing to see great people here. You're just a great mind by just being in this place. So thank you so much for coming. As the MC mentioned, I have been the chairperson for the previous conference, and also among the founders of the conference. We started it just started as a small idea with about 5-8 people in 2017, and here we are with such an amazing team. led by Quincy and Isabella, so we're really grateful. So I'm currently in 5th year, but I can remember 5 years ago, actually on my first day of school, after allowing me to remove my mask, you're breathing so fast. Yeah, so when I was in 1st year, when I went back home after my first day of school, I remember my dad asking me, how was your day? What did you learn? I'm like, oh no, you can't believe how my day was. All we did today was Newton's law of motion, Newton's law of magnetization, Newton this, Newton that, like the whole day. In here math, it's Newton. Everywhere physics, Newton. So I told my dad, I actually think we're in school because of Newton. And my dad laughed, and he asked me a very rhetorical question. He asked me, so is it that you're in school because of Newton? Or did Newton study because of you? And that night I kept thinking about, like it got me thinking so hard, like, by the way, most of the things that we actually do we do them because it's ours, is it for us, or is it for other people? And that's going to bring me to my main point of today, the power of the ripple effect. The power of the ripple effect. Like something small that you do now, an action so small can make a big difference. And I'm just going to give you a few examples of that. We know the Salt March by the famous Gandhi. It just started with a march, and you can see we even have Gandhi wing. Someone from India, his small action rippled affected all the way to Kenya. You realize it's the power of the ripple effect. We also have Rosa Parks in America, who was just seated at a bus, requested to stand for a white person, and she's like, no way, I'm not standing for this. And what she did, like she just did something so small, that ripple effect, that a black person right now in America can have a seat with a white person next to them, just from Rosa Parks' small act. And let me bring it closer home. Just talk about this conference. We know that this conference, as I mentioned, started with about an idea of 5 to 8 people. Just like, not really attending, but basically organizing the conference like behind the scenes. And over the years, I've seen the conference grow. We have attracted different nationalities. We have had Uganda on board. Last year, we had the ambassador of Israel. Also, we had an Australian student in the building last year. So it's just the power of the ripple effect. Another thing I can say also, if you look at the organizing team, you will note that they're all young. The time we were starting the conference, I think I was the only youngest person that time. I'm the only remaining among those. The rest have graduated, they're working. Like it was, I was probably the youngest, but right now we have so many first years, second years, like junior students, because somebody decided to start when they're young, and now other people have also chosen to also start when they're young. Not just wait till 5th year for you to organize something big. You can do it even now, because I strongly believe in the power of the ripple effect. And I say that to bring 3 lessons to you guys. Always when you start something, no matter how small, have the end in mind. We may not have seen it so clearly then, but we knew we want our conference to be big. We knew that we wanted it in Manchester area. Probably one day we'll have it at KICC, but we knew for sure the end goal is to have it big. And we also know even from now, we still want the Americans and Chinese and Japanese to get attracted to such a conference. So always start with the end in mind. The second thing I can say, do not despise a small start. Do not despise a small beginning. Because you know what? Every small action that you do, you might meet someone here that will spark. We have legend. Legend has it that Isaac Newton, he was just sitting under a tree, and then boom, an apple fell on him, and suddenly we're learning all these Newton's laws. And it was just an apple, as in honestly. But that was a small beginning that's ripple affected to what we have now, all those laws that we have now. And lastly, I would like to say, start with where you are, with what you have. Do not wait to own, some building or own a company to make a difference. or own a social network that changes children's homes, just start with what you have. Speak to someone. Probably like here, I know there'll be innovations. So I know probably some have the end goal for them is the money, the prize, but do not, just start with what you have. Like, don't worry that the project looks so small. It will make a difference, like if you keep persisting. And yeah, that is basically what I can say. And I will end with one of my favorite quotes that I always mention. You do small things in a great way, and eventually they will become great things. Okay, so
Good morning. Good morning. I hope you're all doing well this morning. My name is Sipa Kinoti. I'm part of the organizing committee leadership team for this amazing conference, and I'm glad I could see you all here today. As mentioned, I'm standing here on behalf of one of our very fruitful partnerships, one of the CEOs, Ms. Rebecca Miano from KenGen, and they sent me something small to say about the company, so I will read. Kenya Electricity Generating Company PLC, KenGen, is a leading electric power generating company in East Africa. The company was incorporated in 1952 under the Kenya Companies Act as Kenya Power Company PC and mandated to generate electricity through the development, management, and operation of power plants. The shareholders of the company later contracted East Africa Power and Lightning Company, EAP&L, to manage KPC. In 1983, EAP&L changed its name to Kenya Power and Lightning Company, KPLC. Come January 1998, the government of Kenya restructured the energy sector, separating generation, transmission, and distribution of electricity into distinct and autonomous functions. With this move, the management of KPC was separated from KPLC and renamed KenGen. Today, KenGen PLC has installed generation capacity of 1,803 megawatts, of which 86% is drawn from green sources, namely hydro with 808 megawatts, geothermal 706 megawatts, thermal 253 megawatts, and wind 26 megawatts. Of the electricity consumed by Kenyans on a daily basis, over 70% is generated by KenGen, mostly from green sources. 85% of the energy generated is green. And I'd just like to add that we are very grateful to have KenGen as one of our sponsors. They have been supporting us for a long time and are committed to empowering young leaders, empowering young engineers, and forwarding the SDGs, especially on green energy. Thank you.
Help me welcome Engineer Kenneth Alworo. All right, that's the future leadership person. Please, Engineer Kenneth Alworo, if you may.
Hi, it's still morning. Good morning. It's Kenneth Alwora, not Kenneth Alworo. Anyway, my name is Kenneth Alwora. I am the ASEC Future Leader Chairman. I'm here to represent our own chair, ASEC, called Henry Luga. I'm here to, and as I see around here, the basic, whatever is comprised in this room is young guys. So I don't really like doing things that formal. I like connecting with the young people as the Future Leader Chair. So I hope you have welcomed me here with both arms. Here to tell you just a small kidogo to your ASEC. Yeah. So ASEC, we like to how do I put this? Promote healthy industry practices. That is one of the best things about ASEC, and ASEC Future Leaders, we are the youth wing of the main ASEC affiliates. Yeah? So the 40-year-olds and below have been handling mentorship under ASEC Future Leaders, but just this week I've been given the chairman mantle. So with the young people here, expect to see us virtually. I would say sometime this year over Zoom, over mentorship. I think last year we did a mentorship with the outgoing class. I don't know if I talked to someone, there's an Alfred or something. So we had a mentorship with the University of Nairobi students over Zoom last year, and that is not going to stop. That is going to continue because that's one of our mantles. And for the people who are going to graduate this year, next year, as ASEC Future Leaders, we're waiting for you to come, to register with us, and we're going to give you the best mentorship, we're going to give you the best networking opportunities, we're going to prepare you very well for your professional interviews, and we're going to carry you on with the journey together as a think tank, because we are very aware that also you guys have nuanced ideas that you'd like to see being actuated. So with those few remarks, I will be seated right here. Any other questions, please feel free to direct them to me. Thank you.
Thank you so much. That's Engineer Mungeria Kirimania.
Thank you very much, the MC. ESA, organizing committee for this conference. I want to thank guests who have come here. I think the MC has said it clearly, wisdom. This is because my age of working experience is much more than your life on earth. So, wisdom is the main thing. Wisdom is everything because it makes you work with diligence and care. So I think I'm grateful to be here. I was invited sometimes early in the year, and I really wanted to be here. And that's why I'm here, despite many appointments I had. Of course, our council, I was lucky, and born somewhere, supposed to have been somewhere out of Nairobi. Then I thought I would not make it, so I was so worried. Then it was cancelled, I think this COVID. Then we were supposed to have a site inspection in Nyeri. Then they cancelled it. It was on Wednesday. So today I said I'm a lucky guy. I want to come and talk with the young men and the ladies more about engineering, especially the innovativeness of engineering. So I think first I'll give my background a bit on my bio. As you heard, my name is Engineer Mogere Kremania. I graduated from this university some 30 years ago. Interestingly, every time we meet, we always talk about university as if it was yesterday. I don't know if that's only happened in our life, but we are trying to create others by being innovative. After leaving the university, I worked mainly for the Ministry of Public Works and Roads, where I was lucky to work both in the structural department for some years. Then I moved to the roads department, where I worked for around 10 years. After that, I decided to start my own business, and that is when Kiri Consult was born. Around 2002, I registered the company when I was still working, but really to prepare my exit. Then in 2004, I left the government and started the company operational. That is about now 17 years. Interestingly, that I always wanted to be out there not being employed. Because when I was in the ministry, when I was a young person, I was not that used to have government houses. And I was allocated a house, but I refused. Because my plan was within 3 years, 5 years I should be out, and I didn't want the luxury of employment. Unfortunately, our time came the Golden Bank scandal that came and wiped out all the opportunities in the country, that things went double. So our savings, we had a group of 3-4 guys, we had saved some money, we wanted to buy some business, do some business, actually Matatu business. But then unfortunately, when we were ready, the inflation doubled the prices. And we were not able to start this business, and we had to stay on in employment. Definitely, it was disappointing, but the good thing is that it really gave me a chance to network. As I grew in the government employment, I was able to work with different people who later on became quite good for my business. It was a way of creating network. So in 2004, I left employment and went straight to my company. We didn't have much work, but fortunately the economy peaked. I think that is when they say Kibaki, people always remember it, especially guys who are in the industry, because those business that you're called come, there's work here. Then when you do it, you're told where you bring your invoice very fast, you have to be paid, because there was a lot to be done. So we are fortunate our company was able to grow quite fast within a short time, and we were able to do quite a lot of work. And we've been growing, and I think I can say that though not as we wish, because always you have a strategic plan, always you put yourself like you want to be somewhere very high. But I think that's life. Without ambition, you cannot grow. But definitely when you target, you will find you do half, or even if it's a quarter of an addition is better. So that is how Kiri has grown. As you might be aware, we do all the field, the civil, structural, that means we are doing roads, we are doing structures, and we do water. This field has always been complementary. Sometimes you find one time you are very low in one, but the other one holds the other and supports the other one. So you need to diversify in your life. When you are doing business, you don't go only one line, because in case of any challenge, then you might find yourself closing. But now, things that started being difficult because of this COVID, as you're saying here, post-COVID. It's been a challenge in the industry because, of course, the economy is bad and many businesses are closed. Especially the building industry for structures has nosedived. As government does not have new projects, especially in the building sector, and the private sector has also been impacted seriously. Water, we have some work with Okdogo, but not as much. Roads, trying a bit, might be better at the moment, the best at the moment, but not as good. So it is an issue of balancing. So what I would say is that what I would advise, sorry, I have to repair my specs so that I can see what I wrote here. I can't see how I need to repair it. These are mistakes. Yeah. So the few ideas I would give about innovation is that you have to be really able to identify needs of others. You have to be able to see the real problem. This problem should not be based on some kind of euphoria or some kind of pressure from the outside world, but it should be real problems that you will get somebody to help. So for you to be innovative, you have to really know what is needed and where there is a shortfall. Then this will help you to get something to do. Once you identify the problem, you need also to move with speed, real time, because this problem keeps changing. So you might find that there's a problem today, but after some time, it's no longer there. So you need to move with speed and be very, very focused on what you want to do. We always say that you need to have the engineering or skills so that you can be able to come with a solution. Without the engineering, you'll see the problem, but you'll not be able to use it to come with a solution. But if you can see a problem and you have the skills and you have the focus, then you should be able to come up with an innovative idea. I did my MBA here after I started my business. I thought it is good for me because I can now differentiate between just engineering and what is business. And what I was taught was that innovation is putting your ideas in the market to be able to have it bought. If you do a research and get a very good invention, but this invention cannot go to the marketplace, then it is not an innovation. It just remains some kind of demonstration somewhere. So you need to have a way of pushing this thing from the idea, from the workshop or from the research, to it being accessed by the consumer. So you need a bit of marketing, you need a bit of financial analysis, you need a bit of being able to manage human beings, because you might need to work with more than one person. So this means if you are to be innovative in the engineering, you need to also have this business knowledge. So don't get stuck only with the engineering. You might want to do a small course. You don't have to do MBA. I did MBA. But as long as you can do a diploma, some course, a diploma, something that can tell you what normally happens in business. Human resource. You need to do finance, management. Show yourself, like what I'm doing a bit here. At least I'm there, so Kiri is known a bit. So this is partly marketing, of course. So you have to be that person who is not just engineering. So these are the main things that I thought I could give as an idea of how to be innovative. Of course, the simple ideas I give is like, you find we have problems, you go to Turkana. I was in Turkana one time. I'd gone to visit somebody there. And I could see guys are struggling to make mabati roof in a very hot place. Very, very hot. Then you ask yourself, okay, this is advanced. Yes, it's advanced. But is it suitable for Turkana climate? Would it not be better if they just say, how can we develop a technology where you can have thatched, like going up in costs, the tourist hotels? Yeah? Why don't you have, and yet there are farms which, they get their roofing material, others, the ones who are considered poor, from the environment. Why don't somebody go there and say, I'll farm 100 acres, and then I'll see that this thing is distributed, people are able to roof with suitable material. So we have to be real, needs simple solutions. Not to see on technology, sometimes you see China with a long bridge spanning 100 kilometers. And that is why you say that is engineering. No, that's not engineering. Engineering is coming with simple solution for your problems. Don't be excited. Don't have what I would call world philosophy, where they direct you. You have to think like this. You have to develop your local philosophy, whereby you know this is my problem and this is what I want to. Another example, of course, is like our dressing. The way we dress. You find it's very hot and you find somebody with a tie and a coat. So you say, are you really thinking? Why don't we, I remember during the rain, the previous rain, they came up with some dressing which they call Kenya. Kenya, it was supposed to be the Kenya dress. It was simple and it would have really helped the economy because people would start manufacturing locally. People would, the tailors would have a lot of work. But very fast we reverted back to suits where you have to wear tailor from Tumba, which is important. So we need to think of our philosophy, whereby we are not indoctrinated, but we look inward and say simple solutions, not expensive, because the expensive ones are not necessarily the best. The final thing, of course, I would say is your life. You have to think of yourself as a person. Know that you're a human being, you're not a machine. You should not be exploited by others. What I mean is the idea of course, you have to balance life. They call it the wheel of life. You have to have the social life, you have to have the family life. Being on the top with the career might not necessarily mean you're the happiest. So, and if you're not happy, then you cannot really grow. You'll be having maybe a lot of money in the pocket, but miserable. So try to balance, have your fun, time to go out. Kama una pesa umesave kidogo, unasema nitaenda hapa Masai Mara or somewhere. Not necessarily Masai Mara, I can even go to Aboreta. You find some people locking themselves in the room, breathing too hard. He gets a first class. But where does it take him? You cannot interact, he's stressed. You need to have some time, tembea, and Aboreta, tafuta rafiki. Finally, you need to grow to be a human being. A human being as well. Ultimately, you're likely a family. So you need to look at, is my family suffering while I'm trying to become too progressive? So these are the things that will make you finally be innovative in your own life, living your life and serving the nation or society, not at your own disadvantage. So if you're able to balance all this, you will not be envious of others. You will not think that that millionaire is better than yourself, because already you're enjoying where you are. You're enjoying your relationships with your friends, and you're also seeing your growth, gradual growth. So I think this is what I would call partly wisdom, the MC said. So I think I've talked a lot more than anybody else. So nasimamia hapo, lakini nasema if you have any other question, if you want to come Kiri, we are there. But we took about at Kiambere Road, Nacho Plaza. You go to the website, you'll see our website. We are coming with a new website soon. We are modifying just to make it more beautiful. What I want to tell you is that you have to be more than the engineering. You know, you have to think more than engineering. You have to be innovative. You have to really be real time, changing the times. So thank you very much, as an organizing committee and all of you who I can see are you have listened attentively. Thank you very much.
Thank you for those who have at the end. Thank you. So my first question to our panelists, I think we'll start from my left going all the way to my extreme left, is how can we, or rather how can the cities of today become the places we need to live in, or rather we want to live in tomorrow? We have seen a lot of urban pollution, we have seen a lot of a failing in infrastructure, our roads are going bad. Our 50 years after independence is when we realized, oh wait, we need roads, we need a super highway, we need to think vertical when it comes to living structures and also office spaces. So what are the steps that we can do to ensure that the lives we want to live tomorrow will be sustained by the engineering world of our today? Let's see.
Good morning. My name is Quincy Wamono. As a part, I'm a civil engineering student. Concerning the urban cities, well, if you walk through the streets of Nairobi, you'll notice that it gets dirtier by the day. If you walk through the streets of Nairobi, your masks are better off on your nose because of the pollution from motor vehicles, generally from the industrialization. There is not enough space for both human beings to walk along their lanes, and then we have the vehicles. So, how can we address this? We need to rethink and replan our cities better. Well, we can't have businesses running into the highways, right? So we need to sit down and rethink. And this is where engineers come in, civil engineers. So, how do we come back to the drawing board and design our cities in such a way that all these activities can take place with a sea of humanity seamlessly and without any conflict? Number two, we need proper management of waste. How many times do you walk in the streets of Nairobi after it has rained? Probably at night, you didn't notice it had rained, then you woke up in the morning, and the first thing that you meet in the streets is flooded streets. Well, that is another engineering problem. So how do we manage waste? Wastewater, rainwater, and sewage water. How do we manage waste, especially plastics, which have become a menace? That's number two. Point number two, I'll pass across. Point number three, it's about something that is softer than engineering, social engineering. Well, we live in a culture where throwing things wherever we want and doing things however we want is the norm of the day. But then, how then do we address that our people will be keen not to litter our environment? How will we have our people prefer vehicles that use green energy as opposed to fuel energy? Well, our culture now in Kenya is we'll get into debt, we'll go get loans to go get a 5-year-old vehicle just for the prestige of vehicle, with no regards to the environment. And then after 2 years, it breaks down and then we leave it at the garage. Well, we've seen so many broken down vehicles around. So therefore, I've given 3 aspects. We need to replan and rethink. Number 2, we need to design better waste management projects. Wastewater from rainwater runoff. Number 2, from sewage, right? Then number 3, I have suggested, I've put across behavioral change, a moral change, and a cultural change. Given that, we'll ensure that our cities are sustainable even for future generations. Just to cement my point is, how blessed, it's a Greek proverb, how blessed is a society? How blessed is a society? Oh, this is much better. Thank you, I'll have my back. Alright. How blessed is a society whose old men plant trees that they won't enjoy their shade. That's what I'm trying to communicate to you. Thank you.
answer the question that has been posed by the moderator. I hope you can hear me, everyone. Moving towards moving towards a future that is, let's say, pandemic. It can take the solutions, the situation of the pandemic. Now, I'm going to talk from a very transportation and built environment bias. Yeah. So we want to create very livable urban areas, and basically what we've been doing thus far is digging us deeper into a hole. So I'm going to use an example of, let's say, if we're trying to solve the traffic situation, yeah, and naturally what engineers and let's say what the nation would want to do is to build more lanes or more road structures that will take care of the vehicular traffic. But in my opinion, and in every other transportation engineer's opinion, I think we need to rethink that philosophy such that we no longer cater for motor vehicles, but now we cater for the pedestrians who are going to crisscross the urban areas, the people who using those vehicles. We need to rethink the policies and the plans and the laws that are in place just to ensure that we are catering for the human beings, the pedestrians, who are using these facilities. So when we're talking about that, we would want to infuse more, and I'm seeing that is happening in the urban areas right now, more non-motorized traffic facilities. So that's basically walkways and all these pathways for bicycles. We also need to improve or just tell people to now start cycling. Cycling is being used as a mode of transportation in very developed countries out there, like China, in Amsterdam, in the Netherlands. So if we are to use some of these ways of moving around, I believe even the carbon footprint will be heavily reduced within the urban areas. And yeah, moving forward towards, I think that would be something very crucial.
Generally, I think I'm just want to add a bit on 2 points, 2 or 3. Mainly the planning, the idea of having a well-planned, what we could call physical planning, generally having proper zoning. This I would look at it as countrywide. We should look at the country as a whole and start saying we need to plan the whole country as one block. This is because there's a lot of concentration in already cities which are doing they're doing quite well. You'll find most people will find it better to come and do business in Nairobi because the facilities are there. There's more of government, central government is there, and facilities are there. So what would help is to really evolve the development in terms of the urban, in that there should be a policy, government policy, that all counties, their headquarters, their towns should come up with development plans that will allow industries, will allow organized transport. And this will make it easier for people to come out of concentrated areas like Nairobi or maybe Mombasa. So I would look at it as national, not the normal local planning of towns. It should be towns that then put together and then looked at and agree that the best way, we want more business, maybe to go to Nakuru, maybe Nyeri or somewhere like that, so that we don't compete over the businesses. Then you find that the counties that are of advantage, everybody is going there. So you find there's overcrowding, you can't provide enough social amenities, water supply becomes a problem. Like now you can see Nairobi has to get water from Morana, the tunnel. You can imagine after that tunnel, there will be need for another one. So we need to see if that, what the waters bring here in Morana was designed such that it is able to take up the load from Nairobi, then it would have been cheaper. So I look at the planning as one of the major issues. Of course, there is a behavioral aspect. You find that in this country, sometimes we have challenges. Even if we increase the lanes to 20, I don't think there will be any change. Because we know our behaviors of our transport system. They try to crowd even if they are alone, one guy, one vehicle. You find that he's driving, he wants to crowd the road. So I think there's a behavioral issue. You find the thicker road where we have cyclists, lanes, they're supposed to be pedestrian. But that's why you find the picky guys are using. So the cyclist is uncomfortable. Or the pedestrian himself is pushed out. Even here on Kenyatta Avenue, you'll find that picky guys are on the footpath. So you find there's a behavioral issue which we need, I think ethics, we need to improve our ethics. Of course, this can be fostered by enforcement, whereby we are saying that the enforcement is so weak that you design a road, but then it's a super highway, but then you have to put a bump. So you wonder, this road was supposed to be high-speed road, but because the guys are careless, there's nobody enforcing speed limits, then you have to put a bump. So you are putting very heavy infrastructural investment, but because of the behavioral and enforcement, you cannot enjoy that facility. So I think if we are able to address those three issues, then I think this can improve the urban.
But in here, in Kenya, it's become more of a habit work. For example, 3 years ago, we sent officials of the Ministry of Energy to Switzerland to go and check out their waste management program, waste management which Engineer Agora just talked about. They came back, but we still have the Dondora dam site, which could be producing far much more energy to power not only Nairobi, but also Machakos and its environment. So if it's planning, I can say we have planned. I can say a lot of funds have gone to planning, but still there's no infrastructure to, there's no visible infrastructure to deal with such. Last year we had a panel and we brought up the same issue, and the question that was, the answer to the question was that there is corruption. But for how long will we talk about corruption? Or what should we do to deal with this corruption so that we move forward? I believe our future, or most of the future of the people sitting here, needs to be corruption free. So what should we do to deal with the corruption, not only at the grassroots level, but also where it has the most at the top level?
I would really think that this is where comes the behavior, because ethics, I don't know, is it out of mischief or is it out of ignorance? But you'll find that corruption to be stopped. It has to be, each person has to play a part. This, I mean, when you're electing a leader, you should be aware that this leader has got those qualities that you want. If you elect somebody and say, who you went to, and that is the only basis you have, then I think you won't go far. But if you knew that this is a leader who has done something, and he can give us and say, I did this, and did that, and you know, because sometimes you are looking even at the MC level, MCA, not even very high. Because if you get good leaders at the bottom there, the rest will sort out. So for corruption, definitely we are all to blame. Because we find we elect leaders based on what he gives you. So if that is your basis, then what do you expect? But what I would say about the infrastructure, I've never believed in infrastructure as a solution. Infrastructure comes later, after disciplining yourself. Somebody said here that first of all you have to control yourself to control others. There's one of the speakers. There's no way you are going to be given a trump. We are calling it the trump. You put a trump here tonight, and in the morning you find it there. Are you going to be able to operate it? Will we be able to obey because there are a lot of lights? You have to have lights to stop people so that the trump passes. So we need to improve our behavior in terms of improving our discipline level. So that we are able, the more you get advanced, the more disciplined you should be. But not trying to build infrastructure to take care of your discipline. That never fills the gap.
Let's move forward. And I'm actually really privileged to have all my panelists from the civil engineering field. So, Engineer Alwara, in 2017, about 150 billion shillings of food was wasted. And it was wasted with regards to, or rather, because it was tossed out and left to rot due to lack of proper storage, due to lack of proper transport systems, and due to lack of proper food management systems. Some of the best tomatoes in Kenya come from the Turkana region, but only half of what is produced there makes it to the large-scale market because there's no proper road to connect Turkana and, say, Nairobi, where the majority of the market is. I come from Theinternational, where some of the best watermelons are produced. But same thing, there's no roads, there are no roads to connect it. To connect Theinternational. In fact, the road to connect Theinternational to Tanzania is much better than the road connecting Theinternational to Nairobi. So my question is, what should we do to ensure such, 150 billion in 2017, that's a huge figure. It's a really huge figure. So what should we do to ensure such losses are cut down and ultimately eradicated?
Yeah, thank you for that question. The solution to it, I think it has to be very holistically thought. Yeah? So you don't just think of the infrastructure. So for instance, you say the road from your area to Tanzania, I think it's the Voi Matatu road. I've been privileged enough to visit that road, and it's quite sturdy. So I think one of the solutions would be, as engineer would say, make now the development plan a whole national, right? You say it needs to be very national so that you pinpoint the areas that have economical growth. There's this fruits, there's all these marketaries and everything. All those areas that have all those potentials, let me say, you prioritize that growth, let's just say those infrastructures, and then also you put policies in place that actually protect those goods and or rather those services to make sure they get to where they are actually very valuable. So if you're planting melons in Voi, yeah, and fine, they will be bought there somewhere, but where is the actual market? So again, we need to really put in robust policies that can, as engineers say, it's not only about the infrastructure, it also has to come from like what we think, like, is this going to help us as a nation? We get. So if we can improve the policies, again, which also is very dependent also on the political environment, you know, people have personal interests, etc. If we can improve those policies, then anyone and everyone has their duty to play, I think we'll be on the right track.
Engineer, one thing I've noted, I've been a bit privileged to travel across East Africa. One thing I've noted that is advantageous about East Africans is when it comes to policy, we know policy. We know how to make policies. The establishment of policy is not an issue. We have very good people when it comes to writing papers. But now the implementation, just as engineer has said, when it comes to the behavior of society, is now the issue. And I think I haven't stressed enough on this. Where does this disconnect between policy making and policy implementation, where does this disconnect lie? 2, what are the steps that should be taken? Okay, improve behavior, that is one. What are the other steps that should be taken to ensure that this gap is non-existent?
Moving. So, for instance, like the infrastructure, when we cry about non-motorized facilities, etc. Now we are seeing roads being improved. Now we are seeing walkways being improved. We are seeing improvement in garbage collection. So again, as I would say, it's just that we create that change from one political environment to another. And you keep on knowing that when a leader is elected, even he comes with his own personal motives, and if those can be arrested right from the get-go, probably it's something that we also need to continue thinking as a whole think tank. But if his personal motives can be arrested straight from the get-go, and bring in someone who knows what is actually good for the county and the country as a whole, I think that would be. So I think just the change of the political environment, to me, that is such an important factor.
Yes.
I think, like, for this oversupply, I think there's a solution to what we are calling content industries. This is why you do a bit of value addition. So if you are doing, you're producing a lot of value, you should come up with saying, what can we do with it? Maybe do a bit of processing, such that it can get another life, we call it lifespan. This is something that is being done by Makueni County. They've been doing the mango factories and other small factories that really has boosted the county. So I think that is one of the ways at a more not a big, but also at a big middle level, we could think of this. I have a friend of mine who was producing a lot of cassava down in coast there, Wale. And this guy, he did 7 acres because he sold it to another factory in Leafy. But he was telling me now he doesn't know how to take the balance. And he's a learned guy, of course. So I told him, why don't you get a simple machine? Don't get producers maybe to that level of that other factory, but to package it in some way. But maybe this guy, instead of coming with the trucks to come and collect from the factory, from the farm, you have packaged it. So maybe a simple machine that maybe can cut it into small pieces. You know, it just add value so that it becomes convenient and you might sell it at a higher value. So the value addition is one of the areas that the counties have to think about. So that each region, whatever they produce, they try to get a way of preserving the produce that can have a longer shelf life.
Thank you, engineers. Thank you, engineer. Thank you, engineers. Quincy, my question to you is still attached to what the engineer has just talked about, the value addition bits of the ecosystem. How can we employ the use of microgrids? How do we ensure value addition of buildings and structures so that they appreciate in value and price over the years? As a civil engineer.
You know, I smile at that question. Actually, thank you for that question. Because it is something that bothers me. Well, I wish I had the privilege of showing to you all buildings. Buildings that were built with some intricate design. People put their intelligence to it, not just the math, not just about the tau XY and the shear and the bending tension, bending compression, not just frame structures. You see, we are undergoing a problem where we are just looking at utility alone in our designs. Okay, for example, what do you want? I want rental buildings. How many units do you need? I need 5 floors, and each floor to have 10 units. So therefore, Koroga City, put up a column here, put up a column here. So it's all concrete. And then if you take a trip along Kangundo Road, so many buildings, concrete, and you cannot bear the sight. It's an eyesore. We have another example. People are using millions to build up homes for themselves. Then 10 years after the fact, they don't want to see. They want to move into something else. Another thing, we spend millions of shillings, sometimes even dollars, to bring up buildings. And then after 50 years, we are more than happy to bring them down for free. Do you see the problem? Okay, if you don't, let me try to put this. Now, how many of you have seen the Sistine Chapel? How many? Sistine Chapel? Sistine Chapel? Okay, Buckingham Palace. Alright, awesome. Can you imagine buying that building? No, you can't. And 10 years from now, will you afford it because it's cheaper? No, it will have appreciated. So, what is going into these designs that we are not putting in our design for our buildings? It is something called the beautiful. It is something transcendent. Because these buildings are buildings which people in any generation, they will marvel and they will not tire. I'm not saying that we do away with concrete or anything. What I'm saying, it is time engineers to stop saying we are not artistic. It is time to put the art into our buildings. Number 2, when Charles Darwin came up with his evolution theory, it took for this reason, because you don't have to think about it to know it. You think like that already. No one has to teach you. In this sense, that it always gets better, which brings about a trend of fashion. And that is something that is killing our economy. In building also. I'll put it this way. We are always obsessed with the new. You have your own building, it's functional, it is good. But as long as you see there's a new thing in town, you want to leave that and go for another. Well, I agree. It's a good business strategy where people will always be rich. But think about the affordability of it. So, what am I proposing? In our buildings, let us bring the art back. Let us bring back the old architecture. One. Number two, why don't we incorporate African architecture in our buildings? Can't we do it? Yeah, we don't have to have gazebos with chimneys. We don't need chimneys, but we can have gazebos that look like manyatas. Yes? And we can use local material. We have granite. We have self-cleaning limestone. Why don't we use this in our buildings? And let us see if we tie up both our buildings. So therefore, what am I proposing? Let us build buildings that in 100 years will sell for the highest bidder. Not buildings that our children will all be too happy to get the sledgehammer and bring down. Thank you.
Because I personally used to wonder why we have medieval architecture and Gothic architecture and so forth and so on. But when it comes to modern architecture, thank you, babe. Let us move. My next question would be to Engineer Alwara. Sorry. Engineer Jessica, in the video we just watched, alluded to Professor PLO's speech in Uganda some few years ago to engineers across the country, across the region. He talked about poverty and ignorance being an industry in which we are there's unfair advantage taken over and over us. So my question is, what can we as young people, what can we as young Africans do to ensure that this overutilization of this industry is minimized and ultimately eradicated?
I will be talking about the answers are many, so let me use myself as an example. In our industry, even as engineers said, it's not like, for instance, if you're a water engineer or you're a structural engineer or a transportation engineer, it doesn't mean that at all times, especially if you have your own practice, your own consulting firm, and your own business, it doesn't mean that all the times you will definitely have a transportation project, highways project, structural project. That's why sometimes some projects like the water project will hold the office if you don't have the others. And there are some times that you actually have no work in the office. You tender and there's nothing. Are you just going to sit back and relax? No. So I use myself as an example. Always take that keen interest to do your own reading, to do your own training online, to do your own, because what I came to realize, even past campus, past graduating, they say we now give you the power to read. People usually don't know what that's like in English. It doesn't mean that now you go and accrue money and you say, yo, I have a degree. No, now that gives you the power to look at more references, more educational material, more industrial practices, what is happening out there, you get. And also, like, not just pertaining engineering or the technical world, I would say. We've talked about behavioral sciences here and ethics and everything, you know. So how about going back to learn, first of all, who are the grandfathers of this ethics, who came up with all this, who are the thinkers, what was going on in their minds. I'll just, as I said, I like using myself as an example because it actually helped me. So in terms of ethics and behavioral sciences, there are people, there's a philosopher called Immanuel Kant or something, I think. There is John Stuart Mills. These are heavyweights in the politics and economics and how people behave. So if you read their ideas, you read their literature, you'll come to find out how even human beings behave as a whole and as an individual. And once you have the upper hand of knowing how basic things go around, I think you can really slash at the feet this industry of poverty and ignorance. And now there's the internet. You can't say, I don't have money to buy this book, or I don't have. You can even go to WhatsApp and ask who might have this book, or who might have this article, or who might have. And within 5-10 minutes, a day even, a PDF is swung away. Now it's up to you. Open that, know what you're going to gain from that piece of material that has been taken. Yeah. So for me, I think it's up to you. You can't sit back and say, I think I was going to be poor, or I think I was going to be ignorant. The power lies within you. Take up that initiative, take up that mantra, always be curious, always stay curious.
Yeah. Allow me, people, you can appreciate this. We are at this precipice where we argue, is education really worth it? Because the promises that you are given for education are really fallen almost a pipe dream. And shuleni soma kwa bidii, uwe engineer, upate pesa, utaninunulia gari. So bad, right? I remember in class 3 when I said I want to become a teacher, my aunt rebuked me that you're wasting your brains, haina pesa. So, one thing we need to address about education, and it's one of the causes of depression in young people, because it does not bring about the gifts and merits that it was promised for by those who went before us. Well, a difference in time, culture, economic troubles, well, factored. But another issue is the education system. Talk to any lecturer, any professor, a professor of civil engineering. Okay, let me just use a lecturer without even a PhD. The lecturer has, say, civil engineering, like I use SK Tour, he's our lecturer for theory of structures. But he knows something to do with electrical engineering. He knows something to do with mechanical engineering. What I'm saying is, his education is wholesome. It is not compartmentalized. While we've been made to believe that once education is compartmentalized, in the sense that you specialize in something, now that's when you make it. What I'm trying to say, that if you're a doctor, you specialize on the right nose, and that's how you'll be successful. But what I'm saying, we also need to check how education is being given, because we are not having problems solvers out here. We are having job seekers. How do we create our own place through education? Let it be wholesome.
Thank you. What can, how can we encourage young engineering students and graduate engineers to develop a mindset? Quickly has talked about mindset and how you need to carve a niche out for yourself. So how can we encourage young engineers and graduate engineers to develop a mindset of innovation as opposed to that only being focused on
Okay, I think I want to take up something. Okay. Yeah, I think innovation, it's really something we do all the time sometimes without knowing, because it doesn't have to be a big thing. But as an engineer, I know it is good to have what we call apparatus, so that you at least can through engineering. Because what you do in the university is theory, so you need some years for you really to become an engineer. When you get registered, then you can say now you can work for yourself. So it is good to, of course, be under some kind of training so that you can become a real engineer. But if you have to then go without employment for the first time, then definitely it means maybe as an engineer might be a challenge to become finally an engineer, because you need to be supervised for you to finally be a registered engineer. It's difficult for you to do it alone. But for purpose of innovation, because we have seen many people who started small some software, and the guy sold it and got some money. Somebody has made a bed that is unique and seat. Those are actually innovations. But as I said earlier, is you have to feel a problem. You have to look around, see what problem is there. That means you might not necessarily need to be in the engineering line. You might need to look at other areas where there's need and try to get involved. Of importance, of course, now is that if you really are not going to engineering, then you need to maybe develop another skill, because a human being has to have a skill so that you can use it to move forward. So you might find yourself, you have to like move your marketing, like do something to do marketing. So the line you take, you should always, as you were saying, try to do a bit of learning, do a bit of, so that you can be useful in that particular area. So you can take any, what I'm saying, any job maybe, is what you're saying, and be able to be good, because I know our time also we had that problem when we left the university. It was down, as I said, there was those issues of bad economy. Many people went to the oil industry to be employed as marketing, as sales people. Guys changed and became accountants. They're employed by Price, Waterhouse, and all those. My roommate is now a very senior accountant, and he was also a very recent course. So it is that you have to be really more flexible to be able to take opportunity of what comes.
Thank you, sir. Thank you very much. Hopefully, we'll make it. Actually, we should. Thank you so much, panelists, for your time. Unfortunately, we will not be taking question and answer as time is heavily not on our side. But thank you so much, dear audience, for listening in to us. You might catch them over lunch at the 5th floor of this building. All in all, have a good day, have a good afternoon. Thank you so much.
Here in electrical engineering. So today I started to learn about it and how we can use an integrated weight system to protect our own infrastructure from the overloading. I seem to be having some issues with the slides. Using an integrated weight system. Now, move on to the introduction. So, we all know that road transport is the most widely used transport across Africa, by extension here in Kenya. And now we know that as a result of this, you can say that road infrastructure really is the primary economic driver. It facilitates the manufacturing processes as the primary economic drivers in Africa. Now, I narrowed down to SDG 9, United Nations SDG 9, which speaks to having resilience, sustainability, innovating around infrastructure. Now, the question that we ask ourselves at this point is, how can we then innovate around our road infrastructure to make it resilient and sustainable? So this brings me to the problem statement. Now, I believe every one of us here has at least seen an overloaded vehicle or experienced really the effects of overloading on our roads, which really include potholes, as you can see that over there. So this really going to continue to overload, despite the fact that we have some measures in place to really deal with this problem of overload. Now, this leads me to a brief review of some weighing methods that are currently in place. We see that we have a static weight station and recently the weight motion technology has been introduced. So if you look at these two methods of weighing which are currently used, you learn that they are usually at fixed points along our road. For example, if you have used this A104 highway, this runs from Mombasa all the way to Uganda. You find, for me, I've seen a weight station at Naivasha. Then I guess the next one is somewhere past Celebrate. Now this really shows that these weighing schemes are limited in the following sense. One, there are placements far apart along the roads. They make the weighing system really susceptible to be escaped by some drivers. That is, we really don't have to pass through that weighing station. So again, the second one is that they are limited coverage of the weighing station. We say that most roads in rural areas are not really protected by these weighing. And yet, in these rural areas is where we derive our raw materials, which we use in our industries, that is manufacturing, processing, and the rest of them. Then again, another issue that we see with this weighing technique is that we usually experience a lot of congestion. Especially for me, when I pass near Naivasha, I see there is some congestion of trucks and this way. So this now brings me to my objective, which is really to demonstrate how we can use an integrated weight system to really combat this problem of overload. Now, as you can see in that block diagram over there, I hope you can see the values. We have the two methods that are mentioned, the static weighing stations and the weighing motion station. So these are currently used, but now an integrated weight system really brings on board the data management system, and now you have your vehicle weighing itself through the use of an onboard weighing system. The design of this prototype really involved, it's around a network which is like a server and a client, where you have your vehicle acting as a client, communicating to the server to send the weight logs. So as you can see, I have a simple prototype. So what happens is when the vehicle is loaded, there's an LCD screen here in the vehicle, and we have a data management system that's residing on a server, either in the cloud or on a physical computer server. So really, now when you load the vehicle, you see the loading on the LCD screen, and you also have an indication, a warning in case that you hit an over, as you can see here. So now the great thing about this thing is that the data collection, that's weight logs, are real time. That is, you really collect your data every other point in time. Then it logs to the database in the cloud on a physical computer when you really experience an overload. So just to show you, this is the block diagram for that is the onboard weight over there. I implemented it using an Arduino and a load cell sensor. Then now, this is the circuit key that I use. So for the results, I was able to collect some weight from this prototype here, where I have there are two databases really. One is local in the vehicle, then the next one is the data management system. So you can see this is time-stamped data, which was collected over a certain period of time. So this brings me to really why should you then consider using such a system. Number one, you find that this system is foolproof. They said that for the truckers or really the drivers of the vehicles along the road, the way is real time and continuous. So they cannot really escape being weak. And then if they overload, the data is really transmitted to the data management system. Then again, there are alternative uses that you can use for this system just other than the weight compliance enforcement. These include the general weight applications in industry. And also I recently saw that the fines for overloading have really been raised. That is about 1.5 million for every extra ton that you carry. So this also provides the vehicle operators with the ability to really overcome unintended overloading. So at this point, I will make some recommendations based on the prototype that I implemented. That one, for my prototype, I was not really able to transmit data wirelessly to a remote server as I had stated in the design of the prototype. So I would recommend the following just around what I was able to implement, that manufacturers of electronics such as the speed governors can really take up this idea and integrate it together with the speed governors just to save on cost.
Judges, you have 3 minutes to just gather your last, your sentiment about this, and also to ask me some questions. I shall be giving you just in any order. Thank you.
Hi. How exactly are you going to implement it? How will you collect the data?
Oh, okay, so as I say that, there is a system of weighing in the industry already. It's called an onboard weighing system. It's installed to the vehicle using load cells or strain gauges. So that's how we collect the data. Then, okay, this circuitry here I have a load cell over here that really simulates how you collect that data electronically.
So the only thing you're providing is the transmission?
Not transmission, the integration into a central system where, like, instead of just having to weigh your vehicle physically, you can weigh it wherever it is and transmit to a central data monitoring center.
Thank you. Have you started budgeting this product of yours?
Process of budgeting?
Patenting.
I have not yet budgeted it.
You should consider, because it's something that can actually work for a lot of freight transport. We require something like this because we have a challenge of either theft or pilferage of goods as we move from one point to another. The only disadvantage you have is sometimes we find goods removed from the trucks and replaced with stones. I would consider you add some kind of cameras as part of your tool so that even the equipment or whatever you're transporting can be visually seen.
What happens in the event tracks is overloaded? So the information is transmitted to everybody first.
Yes.
How does that protect the rules? Because your aim is protecting the rules. So how do you decide those two things? And I think the other question would be, you should also consider quick, because if you look at our roads, most of our roads have stations near away from those tracks, still side and side tracks. But on a normal road where they're moving, there's not so much in the station, so that's also something.
So,
Yes.
was there a question?
Yes.
Okay, so I'll start with the second question that you mentioned. Now, there are specialized manufacturers of home-built systems, such as National Instruments, who provide you with a system that's really compensated. So, like, okay, the accuracy is a bit low compared to the static way, but it's useful in like flagging down those who have exceeded the loads. Then again, you asked about how it really protects because I'm transmitting. So there's, okay, just like the way the speed governor works, you could bring around some legislation. I didn't want to touch on the legislations because now we see. If you say you stop the vehicle, it will bring some legislation. So basically, I just send it to the database. Then now the authorities such as Kenya can follow up on this. So it will act as a deterrent.
So, welcome. As I said, I'm Charles Kenyo. I am a research assistant together with Joseph Udiro, and we are studying for data soil. So, our project is sustainability through resourceful utilization of plastic waste in construction. As we know, globally, per every minute we have 1 million plastics that are bought at every 1 minute. And so, as we come up with a solution, how do we integrate sustainability in the construction industry by resourceful utilization of the plastic that goes out there? We know that plastic waste is a rampant issue in our current environment. So plastic pollution is known to cause a lot of problems such as global warming, land degradation. And so we came up with a way that we could actually use our plastic waste to construct buildings. Actually, what we are doing, we are not changing the structural elements of our building. Actually, what we are doing is we are just changing the design of the wall structures in our buildings so that we can be able to achieve efficient way in which we reduce the total time that is used in construction of a building. And secondly, we can also be able to reduce the labor costs, and also that way that we can be able to use the plastic waste that is out there into construction of our buildings. So, our objectives actually was to reduce plastic waste and also to reduce the labor costs. So our methodology and the materials that we use, we have used plastic bottles, that is, they can range from 300 to 500 to 900. And then we also have water, we have a brazing welder, we have a brazing welder, we have a wire mesh, we have a ready-made steel rebar frame, we have sand, we have cement, we have gypsum. Wood gypsum is optional, and then we have graphene. So, to that picture as you see, so this is what we do. So we first of all take the collected plastics. Collecting 1 kg of plastics goes for only 17 shillings. Compared to the buying 1 ton of construction stones that goes for actually around 17,000 to 21,000. So you see it's cheap. So for us to get up plastics that we need to make a wall structure, actually it's more cheaper. So we first of all wash the used plastic bottles to remove any dirt. Then the other step we do, like we make a box profile. This box profile we make it out of the wire mesh, and also we have the steel bar, which may consist of the from D10 to upwards. But it also depends on the specification of the buildings. Then the other thing is we take the bottles, we have filled them with water, and then we package them in our steel boxes. And then after constructing them, after filling them in our steel boxes, then we close up our boxes. That is one we weld our boxes together, and then now we stack them like a wall up high. So after doing that, after we stack one box on top of another, we do what is called we do the welding. And then after doing that, we take our sand and cement. So we do make mortar, and then we just plaster the walls. So for 3 things like the beams and the columns, we do not alter, we do not add plastic to them. So you can construct your beams and your columns just as they normally they are constructed. But actually what we are changing now, we are using our plastic waste. Yeah, thank you. We are using our plastic waste as a way to bring into alter the wall structures. Now for us to come up with a finishing, we can use graphene. Graphene helps to increase resistance and flexibility of our buildings. So our advantages is that our plastic walls are able the plastic walls that we have made are able to withstand extremes of heat, cold, and dampness. That is actually we have modified by using graphene. The other thing is that our houses, strength-wise, they are okay because they can withstand hurricane and strong winds. They are easy to maintain. Also, the wall structure, take a shorter span of time. Actually, it requires you for 5 days. You can have your house completed in 5 days. That is, you don't have to use the beams and the columns if it's for a simple house. And actually, it takes you a maximum of 50 days for you to complete your house. And then it's also cheaper to construct than normal houses. So the conclusion part as I wind up is that for us as Kenyans and as people in this global in a global world, we need to think different. Actually, how can we be able to incorporate the problems that we have to solve the problems that are already existing? So for us, my recommendation is that we can take up this project, and also it is open to ideas. Like you can always have ideas to this project. Another thing is a call upon anyone who wishes to invest in this project. Actually, they can come up and they can support us. So thank you.
Thank you, Charles. Now to the judges, you are free to ask any questions.
Thank you, Charles, for your presentation. Do you have any example? Have you done a prototype or a small construction using the materials that you suggested?
Yes, we have done a prototype back in school. We could not carry it along. Yeah, but it was actually we are 60% of the project.
Yeah. Any photos?
There's a photo included.
So that's the one you have.
Yeah.
Good presentation. I have a question. That was actually one, what is the strength of your new material? Two, could you just one only explain how it works? You're stacking your plastic containers in a certain way, and why do you need water in your plastic containers?
So you can take me to the slide that has that picture. So as the picture comes up, so we do make, we have the wire mesh and we have the reinforcement bars. So we do make, sorry I didn't mention the dimensions, we have a dimension of 30 centimeters by 45 by 2.5 meters in length with that is the thickness. So we do make like a box kind of a thing that has reinforcement bars and actually a wire mesh around it. It's like a trap you're making. And then how you fill your bottles, that is, they are filled with water. Why? In case somebody may ask, in case of a fire breakout, what do we do? Like that water inside that bottle acts as it's like it's an extinguisher. But if you're not actually going to do that, we can also add a sprinkler system inside the wall that you can actually turn on if there is a fire breakout. Yeah. Yes.
So how do you, what is your effect?
Like water isn't enough. And we can always modify, we can always modify, like in case where we are there is a occurrence of a fire, we can always modify it actually by using either altering to the design of the extinguishing system in the building.
And essentially, if you're trying to really a construction farm, it'd be nice to see how it compares standpoint to brick and mortar or any other material. It'd be nice to see that comparison, so then you can see where it is up to the technology and
In terms of strength, I would say, like, its strength is okay, because actually the strength is not based on the plastics themselves. There is a steel reinforcement that you're using.
Hi.
What's the aim of the bottles? Because you seem to already have a structure frame, you've got your beams and columns. So why are you introducing? Was it just to make your project fall into the SDGs? Because to me, I don't see why you need it today. You'd rather as well just have done gypsum boards and just clad it with gypsum boards. The thing is, actually, we are reducing costs. You know, I compared when I say it is cheaper to acquire plastics that are always out there than buying, you know, a ton of masonry bricks or building stones. So this one is not just for any, you know, it actually depends with what you want to build on. You understand? So by using plastic actually as a wall, actually it's something that we are now reducing plastic out there. Our main objective is to reduce plastic waste out there. But also it comes to advantage where we have to reduce the cost of buying, you know, some construction materials, and also it comes in terms of labor costs. You know, for you to build a house with these other masonry bricks and stones, you find that you take more time. It takes more time for you to build that. Yeah.
Okay, thank you, Charles. You can clap for him.
Hello everyone. My name is Arnold from University, a 50-year student. We present a project on the desalination of saline and brackish water using constructed wetlands. I'd like to invite my research assistant, Charles.
Hi again. I'm Charles. Thank you. So, welcome to our project that is desalination of saline water and brackish water using constructed wetland technology. So, as we know, sustainable development is one that does not that uses the present solutions that are there without posing a threat to the future needs that will be there in the future. So, as we all know, desalination is a sought for problem globally and even in our country, Kenya, considering where we have actually the percentage of saline water that naturally occurs in our world is actually much more compared to the fresh water we have that is available for consumption. Actually, it's the one that we have, actually, that the fresh water that is there for human consumption is 0.5% compared to 97.5% that is there is saline water. So, desalination techniques that have existed have been achieved, yes, but actually, eventually, they have posed more threats to the environment. One, we know that the thermal desalination and the reverse osmosis desalination actually has posed a threat when it comes to environmental degradation. One is, by the use of fossil fuels as a source of energy, we find that they have caused the environmental pollution. Secondly, the discharge of highly concentrated brine water back to the sea has led to the degradation of aquatic life. So, with my research team, we resolved that we are going to use constructed wetlands technology to achieve our desalination. And so, what does our project entail? One, it entails the construction of our wetlands. Secondly, it entails the construction of a recirculating aquaculture system. Thirdly, we have the construction of graphene sand-coated rapid filters. Also, we have the construction of an electrolysis pond. And thirdly, we have now integrated the advanced greenhouse technology into promotion of the sea saltwater farming. So, what entails when we come to this? So, after we construct our wetlands, the first structure that we construct or that we equip with is a recirculating aquaculture system. The other reason is to promote seawater, like the farming of sea salty water species, like the fish, we have like the oysters, which are a very good source of protein. And actually, the significance of this is that these aquatic animals, they nutrify the water. So they nutrify the saline or the brackish water in our project. Secondly, this water flows to constructed wetlands. And the constructed wetlands, they have plant species like the mangrove, papyrus, and reeds. So the significance of this is these plants take up the nutrients from the nutrified water that has come from our recirculating aquaculture system. So they also take up some salt content from the water. So by this time, our salt or saline water has a reducing salt content. Then after that, this water may be pumped back to our recirculating aquaculture system using the solar energy, or it may also flow to the electrolysis pond. What happens in our electrolysis ponds? So in our electrolysis ponds, we have carbon electrons that are dipped in the water, and this one will actually aid in minimizing the salt content in our saline water through a process known as electrolysis, where we find that we can harvest salt from our water at the electrodes, or which happens occasionally. And our electrodes are connected to a power source, that is most probably DC. Then after our electrolysis ponds, our water goes three ways. One, it goes to the graphene rapid sand-coated filters, and this one is for the purpose of filtration and water treatment. And after the water goes through the filters, the water now goes back to, it goes to the storage tanks, which at this stage is good and fresh and efficient for consumption. Okay. The other thing that we do have is that our water goes to the wetlands where we can have further crops grow, and it also goes to the greenhouses where we find that our water can be used in farming for things like maize and fruit crops. So thank you. Thank you, Charles, for the introduction. Now on to the objectives. The primary objective is to be able to provide an efficient, sustainable, cheap, reliable way to produce fresh water. As we know, the desalination method, they exist, and they are very, very expensive. So if we pay attention, our project it will be able to provide a cheap and reliable and efficient system to provide fresh water for consumption. Number two is to enable farming. Is to enable salt water farming. And number three is to be able to enable aquaculture in dry and marginalized areas through RAS system. So controlled by Kino, the RAS system is simply the recirculating aquaculture systems, which fish are able to be fished, as well. And number four, we have the utilized wastelands through saltwater farming. And number five, it finally promotes green technology in our deserts and in other regions. And let's go to the methodology. In the construction of these wetlands, we need to carry out survey so as to be able to understand the topography of the location. So as when you are constructing a wetland, you need to know the physical characteristics that exist. This helps us to enable the method to be cheap, as we are relying mostly on gravity to be able to flow through the constructed wetlands. Number two, we have the designs of the rapid, the recirculating aquaculture systems. We have been told that it's a system that comes from the recirculating the RAS system, and then it goes to the construction of the wetlands. After the construction of the wetlands, we have the construction of the electrolytic ponds. After the construction of the electrolytic ponds, we have the construction of the filters, whereby after the electrolytic pond is separated into two. One it goes to the greenhouse.
Now we welcome the judges. Let's clap for him.
Thank you very much for your presentation. I just have a question for us. I want to know, in terms of scaling this project, will the costs reduce as you scale this project, let's say across the coast region or probably at Sana and other conditions?
Thank you for your question. So the cost will scale down, actually, because we consider for the construction of a desalination plant, actually, us working from around 50 million to up on the scale. But with the construction of our wetlands, according to the size and also the water that we need to the water need, the water demand we expect to have, it can range from 150,000 Kenyan shillings to construct a full, wetland, actually up to 1 million Kenyan shillings. So it will scale down the production of water. And for you to produce a liter of water, for the desalination techniques that have existed there before, you need 150 shillings for you to produce just a liter. But with this one, you actually require less than 10 shillings for you to produce it.
My dad and I used to go to the farm every morning, 6:30 a.m. The reason why we used to do this is to identify crops that are maybe affected by diseases so that we can plan our day. I used to drive this. The reason why I drive this is because I'm not a morning person. It was very hard for me to wake up in the morning. Also, why did I have to go to the farm? Was it a must that I go to the farm? Was there an easier way? So last year, my friends and I were discussing about this idea, and we were thinking, why wouldn't I run my farm the same way I run an organization as a CEO, a business admin, a manager, and so on? And we kind of thought, why, if we could have data presented on maybe a tablet. In the morning as I'm taking breakfast as a farmer, I get all the stats. I have risk analysis of my farm. I know I need to go spray. I know where my crops are affected. Each and every morning I receive all that data. And from that data, I make good business decisions. I know how to plan my day. That's just from sitting on my couch as I'm taking my breakfast, as I'm taking coffee, as I'm having a conversation with maybe a spouse, my friend, wife, and so on and so forth. So that's how I came up with Shamba Langu. So the objectives of Shamba Langu is to provide real-time farm monitoring. Also, we provide predictive modeling and analysis of risk in agricultural farms. To improve yields through early disease detection. Take it for instance, you're in Nairobi for maybe an agricultural conference. You need to know what's happening with your farm. And you probably don't have good, what do we call them? The farm workers. Yeah? You get your data and you can know your whatever is happening in your farm in real time. The other thing is what to improve efficiency of farm operations. As I said, you have data early in the morning or in the evening or whatever time of the day and you make your business decisions. So how do we get this data? Image classification, that's AI. We employ machine learning to detect diseases, detect pests. The other thing that we also want to provide is simultaneous localization and mapping and geographic information system mapping. Basically, that gives you such a thing. You have the green areas where you know your crops are doing well, then you have the yellow areas where you know you need to go spray, or water is not enough, you need to go irrigate, or water is too much, you need to figure out what to do in that section of your farm. The results that we want to achieve is to have a happy farmer, a farmer who has managed the farm well with less effort, and also want to incorporate drones for spraying. Why would you have workers in 21st century with a big tank on their back going like this spraying crops? It takes time, there is wastage, pollution. In conclusion, we basically want to make farming better, easier, enjoyable for people like me who don't like walking around looking at things.
Now we go over to our judges.
Thank you very much for your presentation. My quick question would be, is this applicable in Kenya? Have they started this? Have you done something about machine learning because of it? Thank you.
Yes, currently we are in Juja, so we have 3 farmers at the Juja farm. One is doing maize, another one is pepper, and the other is cabbage. Yes. So we are trying to roll it out.
So you already have created images and you're monitoring the same way?
Yes.
Thank you.
I'm just worried about your data. Could you just explain more about how you're going to collect this data and how you're going to use it to train your models with the information about AI and machine learning?
Okay, so for example, for disease and pest detection, we have a multi-class model for different pests, different diseases, so you can detect whatever disease is affecting a specific crop. And for collecting our data from the farm, our main sensor is a camera, which we use to determine crop spacing, just to monitor the general health of the crops and also to do the analysis for the image classifier. We also have other sensors like soil moisture detection, so to track the water content in the soil for the plants.
Hi. How will your camera pick up the amount of the soil moisture?
Our camera doesn't pick up soil moisture. It's done with a sensor.
So the other sensors as well?
Yes.
Why did you use photos of what you've done if you wanted in Julia? Instead of giving us some foreign images from the
we don't have pictures running up the picture, but yeah, you can follow up with us. We can show you how to do things.
Do you know who your competitor is? Airbus. Airbus is now providing farmers with all the data you say from their satellites in the sky.
That I think is less useless than us because we're using drones and we can get a much closer image than satellites.
Last question. Have you had a look at the time complexity of this? How long will it take for you guys to control all this
Even for SQL classification. This is a single classification. So, like, currently we have, like, I think 10 diseases and I think 13 pests. So, the more we roll it out, the more we try and train the classifier to get more pests and more diseases.
Okay, is that all from the judges? Oh, that's okay. We can clap for them.
We get to present IoT device that helps us save energy in our homes. Yeah, thank you.
Good afternoon. Nairobi is estimated to have a population of about 4 million people. Out of these 4 million, 1 million people live in farms. The World Bank estimates that 75% of the population in Nairobi have access to electricity. However, this is the percentage is not very bad, although it could be better. The problem is that out of this population, only 7% of the population monitor their energy consumption. Now, in a third world country, such as Kenya and any other developing country, energy monitoring is very important so that you can solve the problem of energy poverty. We have a device that is WJZ, whose main objective is to It monitors the energy consumption for a user and also gives the user proper suggestions and from the data it has collected so that he can make well informed choices. We also issue, the device also marks informed statements. And also, it can provide an interface where the user can make payments for the electricity bills. So how we are doing it? So we are having a current sensor and a voltage sensor where we can from these two parameters we can get the power consumption for the user for all the devices, and then we analyze the data where we from the models we train we have assigned an energy signature to different devices, which makes sure that at any time the device it can relate to the user which appliances are on, and it can also tell them him or her the power consumption. And also it allows for device will allow for remote switching. This is very important, especially let's say for us engineers. Let's say you have a day job, a 8 to 5 job. Yet let's say you're coming up with a prototype or something. So let's say you need to perform 3D printing or something. For certain complex designs, we know that 3D printing will take a while, like 8 hours, 7 hours, and you don't want to really stay there since you have a day job. You don't really want to stay next to the 3D printer. So it can tell you, you can monitor the 3D printer through the device, and then you can, when the printing is complete, the remote switching will allow you to switch off the machine for any other plans. So what you can see there is one of the components we're using, intercurrent sensor. It's connected to the live terminal. It gives you real-time data for the current that is being used. There is our circuit. We are using an African stocking was able to give us proper data, whereby we also perform filters. And we average the data, like over 1 second, we can have like 100 units, so that you can average them to give you proper data. And our models, we're currently able to predict the fridge, the television, and the microwave and water heater. With using the energy signatures, with 93% accuracy, we can tell exactly what device is being used. Then we are working towards complicated machines such as the dishwasher and the washing machine. And we think the device has potential because we can apply it in the industry. Since if you know the energy signature of a machine, you can tell like when you have an anomaly. Therefore, which will create wastage, it will flag, and then you will know that the machine is faulty. So there is our data. It's collected from a home. And at the low point, you can see this was the fridge, operation of the fridge. And it spiked and the water heater went on. So basically, what you see is a current.
Thank you very much for your presentation. I would want to know the cost of your device once you prototype it. How much will it cost?
Around 3,000 to 3,500.
That's the cost of making the device or selling?
The cost of making, but now when we go into production, you can scale down whereby you don't have like to use a big board, you can just use a small microcontroller.
Where will you be housing your data?
The data, okay, so at the moment, we are currently collecting data on, just like this, showed you, both fridges and microwaves, such that if you plug it in, it will note the energy signatures, and then this will also be uploaded. We have like a central database where every other current sensor can access this data and actually tell you what devices are on your specific data, the specific network. So the rollout is you'll have like a mobile application linked to your current sensor, to your device, the choosing device, that will personally tailored to you. So you know what devices you're currently running, but the model and the data is stored in the cloud.
So the connection for the data, you will have it near the energy meter or just at the energy meter or the consumer unit where you plan to install?
So for local consumption, we hope to put it in the consumer unit where all the electricity of the house goes to.
Thank you very much.
Hi. You're sure you got energy signatures?
Yes, we're sure.
Then you should be millionaires.
We hope so.
One of the companies that like to people in Silicon Valley and exactly the same story in US. And when you are finally pushed to actually identify the data.
We've tested and it works on, let's not say like one of us, but of a couple of devices. We are saying that we can predict with 93% accuracy that this is a specific energy signature. But we are not promising that you're going to always, when you plug it in, this is the device will tell you exactly what this is. We also have to aid the device to know what this is. So when you plug it into your network, you can also aid the device by telling that we have a fridge. So what the model will do is try to relate all your appliances to specific energy signatures. So we know like a charger, when you plug in a charger, you can use like 0.2 amps. So you don't expect that when I plug in my TV, it will also use 0.2 amps. So the model will be able to detect there's an extra appliance on your line because it expects that a charger will only use 0.2 amps. So we're not saying that we've discovered how to completely detect energy signatures, but we are saying that we can identify, if you've given this data, we can identify this is the signature, and we can identify anomalies. Because we hope that when we are tracking data over a long period of time, we can tell that your fridge used to perform at this level, but it's now performing at this level, which is an anomaly. And also, we can help switch things off when you're not around, because it allows remote access.
Thank you. I guess that's all from the judges. You can clap for them.
Yeah. My name is Siraj Ibrahim, and I'm the leader for the research that is actually me. I was doing it with 6 members from the University of Nairobi, from different departments, that is the mechanical department, the special department, and the assistant department. And we're actually doing research on how we are going to reduce plastic waste and the effect of plastic degradation in the world and in Kenya. And this is actually the session that I'm going to give you. In Kenya alone, we are actually producing more than 20,000 tons in Nairobi, more than 20,000 tons of trash daily, out of which 80% of that is plastic or actually related to plastic products. And we're asking more questions. Plastic takes a long time to degrade. It takes a long time to decompose into the soil. It's actually deteriorating our agricultural land and making all our landscapes look ugly. And the reason for us doing this research and process was actually to come with an alternative way to reduce plastic waste and the impact of plastic waste on the environment. And so one of the solutions that we came with was the conversion of plastic to fuel by a process called pyrolysis. As we know, fuel energy sources play a vital role in our daily lives for transportation, heating, and cooling purposes, and providing electricity. Due to this, there is need for another source of fuel other than the renewable fossil fuels. Fuel can be produced from organic compounds which are converted into useful hydrocarbons. As you all know, we're actually trying to reverse the process of plastic production. When plastic is produced, large, small chain hydrocarbons are condensed together so that they make plastic. So the process that we're actually doing today is to reverse the process and breaking down the condensed large chain alkenes into smaller chain alkenes. And the reason for this is plastic does not break down in the landfills, and plastics can be easily recycled and degrades in quality during the process. And the amount of plastic that is recycled in Kenya today is only 20%. Can you move on to the figures, please? To combat this waste to fuel, pyrolysis process is is utilized, which involves the thermal decomposition of the feedstock, which is plastic waste in our case, in oxygen absence. So the chemical composition and structure of the feedstock affects the pyrolysis process used and the output process. The types and plastics are polystyrene, polyethylene, polypropylene, polyethylene, tetrapropylene, which we interact with in our daily lives. Okay? During the process, we actually put the plastics in a reactor, heat it, and then in the absence of oxygen. So when you actually heat it in the absence of oxygen, rather than the plastic melting, it breaks down into smaller chain alkanes. And when you condense them back, whatever you get at the end will be fuel. The fuel can actually be condensed into different components, that is gasoline and petrol. And the other part that actually be left as a residue after the combustion will be coal. And coal, as you know, can be used as a source of fuel for the production of the same. And then the gases that have not been condensed will actually be taken back into the process. And so, for this reason, I say that actually the process is fully efficient and no energy consumption will be used after the first batch is produced, because the gases and the coal that has been produced in the first process will be the one to be used for heating the other parts. This is the diagrammatic representation of the process. As you can see, we actually have a heater, and then as the plastic is being heated in the presence of catalysts, that is aluminum oxides, zeolites, and calcium hydroxides, they actually move forward and then they condense into different components, that is waste oil, diesel, gasoline, and different gases are actually going to be used back into the heater reactor. The next page. Based on the previous research, this chapter investigated the fundamental plastic processes and reaction with temperature increasing. Plastic will go through the glassy state, the rubber state, the liquid state, and decomposition. The decomposition of plastic in an inert environment into liquid is called pyrolysis. That is the process I'm actually explaining to you. It was found that heavy molecular weight hydrocarbons produced from primary cracking can be further cracked into molecular weight products through secondary cracking process. So if the plastics actually had not cracked in the first batch, then it can be done the same in the second batch, so we'll end up getting an efficient system. Moving on to the next slide. So in conclusion, the project shows some light on the possibility of manufacturing liquid fuels which could be used as feedstock refinery for further modification or commercial use. By using this technology, we could solve the waste plastic problem and also significantly reduce the landfills which are the cause of infertility of agricultural lands. Waste plastic can also become a very good source of energy and an alternative to fossil fuel, which have caused an environment imbalance. Thank you.
Thank you, Dr. Now let's go forward to the judges.
Thank you very much for your presentation. My comment is, looking at what you have presented, is a good technology. My only challenge I have is the cost of setting up. I believe you put it maybe near a slum area, having a dump site, and even conveying that material to the plant is still going to be also an expense. How do you take up for that? And who's going to use this technology?
Thank you very much for the question. This technology is going to be used for commercial use, that is actually on the national level. We have the Dandora dam site. If at all the Dandora dam site actually to have the same setup, the amount of electricity that you can generate is so immense, or the amount of fuel that can be generated from that and then converted into diesel and jet fuel and oil will be so immense. And I think that's it. Any other question? Thank you.
Okay, that's all to the judges. Let's clap for him.
Crop production is lost due to pests and animal diseases. This accounts to almost $220 billion every year. To put that in perspective, we need around $100 billion to end world hunger every year, according to the Food and Agriculture Organization of the United Nations.
With our project,
With our project, we aim to save up to 70% of the identified above glitch in the agricultural sector. We are also working in line with SPG number 2, Zero Hunger, and SPG number 12, Responsible Production and Responsible Consumption. My name is Victoria Munove.
And my name is Dora Rotich.
We are both from the Department of Engineering, Electrical Engineering and Information. ShambaCare is a mobile application that utilizes the process of image processing to identify, diagnose crop diseases and goes ahead to give the possible solutions to be addressed to these diseases.
As my partner has ably introduced our application, the objectives of our mobile application is to provide a real-time diagnosis of crop diseases, give the preventative measures and the solutions. Through that, we aim to educate the farmers, and as we collect data, we hope the data will improve the said detection algorithms that we're using.
The flow chart shows how our application runs. First, we apply the image, the app then loads it and provides to the farmer the identified crop disease and goes ahead and gives the control measures of the disease.
Yes. This is actual screenshots of our app. As we can see on the first slide, this is our feed. It shows all the diseases that we were able to diagnose using our app. The second slide gives a library of all the diseases that we can identify in the application. And on this slide, it actually shows a disease that we were able to diagnose. This was early blight, potato disease, and as you can see, we were able to give the control measures and the preventative measures.
So these are our future plans. We've already worked on the crop disease detection, and this is what we aim to work on in the coming stages. The first one is IoT by provision of smart farm devices such as temperature detectors, humidity detectors, and also incorporating of smart and automated irrigation systems. The second one is the crop cycle management. We will be able to give the farmer well-curated data. Therefore, the farmer can have timely planting, weeding, and harvesting of the crops. The third one is the marketplace, which helps us bridge the gap between the deficiency and the demand in the crop production.
We aim for ShambaCare to be a complete one-stop shop solution for all farmers. This is how we plan to make money using our app, through marketplace platform commissions, advertisements and recommendations for relevant applications, premium subscription, curating and selling our data, and also a ShambaCare smart farm management system.
It is with great faith that we have in the ShambaCare application that we look forward to increased and more productivity, easier management of our farms, and timely and well-curated data to help our farmers achieve the best farming experience. So, as engineers, we have not worked alone. We would like to acknowledge Elkanah Tuwei and Kevin Kibet, who are both software developers, and they have seen to it that the app actually comes to what it is right now. Yes.
Yes, so thank you so much. We'd like to give our judges a real-time and usage of our app. So this is our app, judges. And we can show you a real-time diagnosis. I've already downloaded a photo. And let's see the app working. It's detecting, and as you can see, we're able to identify this plant has leaf mold. Yes. So thank you so much. This was ShambaCare, where we protect what you sow.
For your very nice presentation. I would be interested in knowing where you're sourcing your data, that's one. And the other one is how you're recognizing potato blight. Is it only color that is used to determine that? And also to determine the leaves of the various plants that you grow. Thank you.
So the data is from open source, from the internet. That is what we've been able to do so far. But in the near future, we hope to roll out the app, and for the different farmers and their needs, we hope to improve the whole AI thing.
was asking how you get your data, and then how do you identify potato blind color, and that this leaf is for a potato and not, let's say, the sweet potato. How do you determine that?
Well, thank you for that. So far, the diseases that we're able to identify are very specific to specific plants. So, but in future, to solve that issue, we need the farmer to enter the type of crop so that it can lessen the issue and so that it can be able to give direct and accurate diseases.
What do these entail? And as a farmer, if I don't have the premium subscription, does that mean I do not have access to all these things that you are taking there?
Everything that we have in the app to be free for the farmers, but we need to make money. This is a money world. So we plan to also bring about the extension of research such as agro-vets, the healthy institutes that do with agriculture, and so some services will be free for every other farmer, but for you to access the premium content, you have to be subscribed.
Yes, but we want to make it very clear that the disease detection part will be free for all farmers.
Okay, be relaxed. All is well.
My name is Joseph Muziro, and I'm from Egypt University. I'm going to present something on papers.
We urge to maintain silence.
Thank you. That's it. These are the impacts, the SDGs that you're looking at are the clean water and sanitation, industrial innovation and infrastructure, sustainable cities and communities, responsible consumption and production. By the end of this presentation, people are going to believe the statement that was put up there. And I'm going to take you on a quick crash program on fluid mechanics. I don't know how much you know as engineers, but I know you know a lot to know that there's somebody called Reynolds, and there's something called Reynolds number. We have laminar and turbulent flow in pipes. So what happens is that when water flows in pipes, we have what we call, it's like a concave. So at the edges, we have drag and friction between water and the inner walls of the pipe. And that's how it looks like. So why is this of interest to me? It's because I come from Eastern Nairobi. And the one thing we hear in Eastern Nairobi, more than insecurity, is blackouts. Because when you have blackouts, Nairobi Water Storage Company wants to pump water from the Kanye Dam. And if you're privileged enough to live in a place that has a borehole, you don't get water if you live in that flat. Ladies and gentlemen, 10% of the world's electric energy, 10% of it is spent in pipelines. We are talking about pumping oil, pumping gas, pumping water to reach people that they require time and volume. 40 to 60% of the water that comes from the water treatment facilities that the Nairobi City is going to supply are going to reach you because it's going to get lost through leakages and illegal connections. What that means is that as an end user, we pay a lot expensive for water, which water should be free. Let's go. You see, the thing is, these pipes were designed 200 years ago to solve the problems of 200 years ago. We live in the era of the fourth industrial revolution. So we need pipes that are going to solve the problems of this era, the problems of population, the problems of everything. And that's why we have solutions, speaking of solutions. Our solution basically is addressing whatever we have right now. We're going to use a pipe monitoring system with hydraulic modeling and optimization algorithms a lot of jumble up stuff I'm going to explain in just a minute. That has integrated circuits, microcontrollers, solenoid valves, communication devices, water sensors, and so much stuff that comes in our methodology. Yes. So how we are doing this? Is that we have the pipe, the equal. So as water flows, the way it's showing, now we're going to flatten the velocity profile so that water flows in a laminar flow. Then this pipe should have water sensors, and these water sensors are going to detect where we have leakages and illegal connections.
3 minutes from
Leakages and illegal connections, and then a lot of water storage company is going to be told of them. Yeah, and this might look like fiction. Please next. Next one. But yeah, this might it's a leakage. Just a minute for this. Exactly. This might sound like it's come out of an imagination, but that's a successful simulation. What you see here is a flow meter component. Now, what you're looking at here is after we've altered the velocity profile, are we getting water to people at the required volume, at the required time, at the required pressure? That's what the end consumer needs to have. And that's what the flow meter. Then the next, that's what the solenoid valve. What is happening here is that are we closing water at when we have leakages? When you detect leakages, predetermined leakages, predetermined illegal water connections. That's how our point will look like. I'll explain that in just a minute. Point looks that weird and new. It's because going next to our design piece. Our design piece next. Because you see the size of that pipe and the size of this pipe. That's how we intend the pipe to look like. Down here, we're going to put all that electrical components that I've shown you. So the most elaborate systems on this planet are pipeline networks. So instead of us cutting the whole pipeline, we're just going to cut a small subsection inside our e-pipes at predetermined intervals. That's for oil and gas and water pipelines. And then what happens is that we have a smart pipe. We have smart pipeline networks. Okay, let's go to the results and discussion. Okay, from the simulation we had shown you, we used Tinkercad. This is how turbulent flow looks like. This is how laminar flow looks like. And now we were able to convert this to a successful rate of 60%. And we think we tend to believe that that's a breakthrough because people know how much, if we just lose 1 liter of oil, that's a lot, that's expensive. That shouldn't be happening. We're talking in the 21st century. So let's go next. That's our conclusion. Yeah, we intend to reach the successful rate to 90%. What else we're getting from this, and this is the most interesting part of this pipeline, that we're having something called big data. That's what moves the current flow because now it only comes from instance. So if we know that Umoja needs 20 liters, for example, 20 liters of water per second in the morning, and a place like Dandora needs 10 liters per second in the morning, but in the evening, Dandora needs more water than pipeline or than Umoja. These pipes are going to automatically, using preset models, we're going to close the valve of the water that's going to pipeline or Umoja, and then we're going to open the pipes that are going to Dandora. You get? If, for example, schools don't use water at night, so there is no point of having water in the pipeline.
Time is up.
Thank you.
Thank you. I think you have removed your nervousness, and I think you know what you're saying. My comment is applying this to Island's existing pipe work, which is old. I think for me it would be easier if, as we are upgrading our pipe work, like what you're seeing here on the expressway and other places, that's when you can actually apply this. The other place I think you can actually apply your idea is probably talking to people like the Konza City. And I think that's where the application can be, can actually work when you're setting the greenfield. Otherwise, it becomes a bit of a challenge until the city, county governments, or the sewage services add or improve their water network. And please apply this also to the sewage part of it, not only the water part. Thank you.
Yeah, thank you.
How are you altering the profile of your fleet? Are you changing the material of the pipe?
No. What we have is this effects, the small effects. Now, using these effects, using of the presets of the things we make, which in the camera will tell you to pass button step. We're changing the recipe program. So we have intelligence what to bring in, let me know what's coming up. And this system down here, that's where we put the electric component. So we're not really changing the pipeline network. We're just making smart pipes, like pipes to solve the problems of this generation. Yes.
I am trying your technology in your Sendora and whatnot.
Yes.
It's barely paid for normal water, so how do I make money?
This is how we make money. We are eliminating illegal connections, we are eliminating leakages. That means, hypothetically speaking, Nairobi's water and storage company is going to have close to zero losses, because if you save money from pumping water, you save the losses that could have been incurred from leakages and illegal connections. What that means is that you have almost all the water that you're producing at the water treatment facilities reaching the people. And if you have efficient metering systems that the consumers hope, that means you're going to get almost zero losses.
So when you're teaching, you put the stats as well.
Thank you.
Hi. Could you say the hypothetical? Because those leakages are not illegal habits. They are very legal. There are people who benefit from those habits.
Yeah.
Yes. So like you're told, maybe talking to something like Konza or last scale, probably would be more ideal. But how do you power your e-pipe?
Thank you. I would have explained that first time passing short, because you see, the thing is that when water flows in a pipeline like this one, we're going to use water flooding sectors. And you have like something like rotating water, something small. You see, the electrical component that we're using here, we're using something small, just not a lot of power, just something small power. So if we have something like 0.001 what's happening inside here that's going to run with the flowing water. That means we're going to power the electrical component down here. That's how we're getting the power down here.
But would you recreate the turbulence?
Pardon?
Would you recreate the turbulence with your turbine?
Now, that's part of what I would say that we will advance pattern, because there's a trick that we're using here. There are methods like orifices and other methods that have been used to successfully relaminate water. And that's what we will employ. So that's part of what we will employ in this method. Thank you.
And Mike Bonera, mechanical engineering, Sophia students here at your hand.
So I will introduce the project. I will take it over from there. So our project is called it's a sensor-guided sprinkler irrigation system. So we are addressing SDG 11, that's sustainable cities and communities. And in our case, we are trying to address water usage in agriculture and specifically in irrigation, and trying to curb wastage and curb inefficiency. So as you know what sprinklers are, sprinklers mimic rainfall. And so, according to the FAO, close to a third of irrigated area in Kenya uses the sprinkler irrigation method. And you find that these, a study showed that 38% of water is used, that's only 38% of water that is used in irrigation actually yields the produce. So our project, you have that the gap that you have, so we want to improve performance. Sorry, the previous slide. Not yet, I'm not done. Yeah, so we want to improve that performance because we find that when sprinklers don't communicate, when sprinklers have there's no way to communicate with the farmer about, let's say the sprinkler is running and then it's raining, so we have that wastage. So we analyze what is there in the market. We delve deep into the technologies that they use. So we had all these systems, and what we found that was a gap in when we looked at all of them. These were the shortcomings that we had. So in terms of cost, either they were too expensive, they did not have automation, they were not easy to handle, the response time was too slow, there was no communication, real-time communication to the farmer, and also they were not accurate. So we moved on to our prototype. Previous slide, please.
So this is a schematic diagram of the prototype. So it uses, currently we have two sensors to work with our prototype. One is a solid moisture sensor and another is a rain sensor. So in order to solve the visual of the sensors, we are just more or less something detecting moisture water. So how it works, the microcontroller, which is an Arduino Uno, receives data from the sensor, and it sends out through coding, it sends out into a reading module. A reading module which acts as a circuit which open or close a circuit with valve, depending on whether the pressure rainfall application. So this, in short, I'm trying to explain that whenever it rains and the sprinkler is still continuing to rotate and supplying water to your farm, our sensor will send data at window saying so it's already water, so it's going to supply to your sprinkler. So it's following the power of a couple of water supplies to your sprinkler, which is it will serve that amount of water that should happen to sprinkler if it's still raining or if the soil has quite some enough moisture on it, enough moisture on it, sufficient. That's not sufficient moisture. Yes, so what we anticipate, the outcomes we anticipate from our project, number one is fast response because it's our microcontroller which is going to be fast and it's cost effective. Making a prototype isn't that even a prototype that we are actually using for so it's not expensive and low energy use because to power it's only the power. And even like this, you can just use a battery. You can use a 9-volt battery for fabrication. Yes, and so yeah, so further improvements are coming.
Time is up. Over to the judges.
I would want to know, in terms of costs, if you are having this 10-acre piece of land and you want to put this equipment, you want to put in every part, and then what kind of costs are we looking at if you are to employ this country?
First of all, especially if you want to the conditions that you're trying to capture is very important. So generally speaking, if it rains, the sensor, you don't have to place it in rain breakers because the rainfall will come out. You don't think it will rain in some part of the farm. So the same thing with the soil, generally said in the farm. So you can only use even one system that can be used.
But you need more than one because if one fails, you can be able to use the other one to detect. So in your design, you need to also look at when it fails, what we call a fail-safe position, the others should be able to give you the right data. Whatever is giving you the wrong information, then it's not activated for it to either switch on and switch off for some reason. So factor that in your design.
Add to what you're saying. Thanks to different crops that have different
Christianity saying connection in the buildings and
it was around 4,000.
We should be able to move on to the next session now. Now, I'd like for the judges to have some peace, some alone time, to just go through the project. So I will lead you back to the VIP area, so you can just go through the project and understand, who is our winning team and why they deserve to win as well. So we'll be having the judges deliberating, and then one of our judges will present the official winner.
Okay. So question is, would you want to be the judge? Would you want to be the judge who decides whose presentation is the best? Wasn't that a tight one, yeah? That was a super tight presentation. We have such amazing innovations coming up stage. It's gonna be tough. Alright, so right about now, as our judges, put their heads together to figure out how that is gonna go down, I think I'd love to usher us into the next session. We're gonna get a few sentiments from some very important people among us. We've heard from them, but they wanna just put things into perspective for us one more time. So please help me invite to the stage Miss Grace Kanye. Round of applause for Miss Kanye. Alright, that's Miss Grace Kanye.
Hello, everybody. It's amazing to see that there's still such a huge number, even in the afternoon. How many lunch do you guys have? I think the committee for giving all of us lunch. I spoke in the morning, so right now I don't really have much to say. Just here to recognize the presence of our guest of honor for the conference. That's Mentor Ida Nana. She's been very crucial to this. She stayed the whole of yesterday, and also she joined us today, so we're really grateful. Thank you so much for being here. And then also, we've had the previous ESSA chairs in the building. Woo! Yeah, it's exciting. It's great to see that chairpersons from so long ago. I think the first one was there when I was in first year, the other one was there when I was in second year. So Rayford Momani, who works at KPMG right now, he was here, but he had to travel today, right now, so he's just gone. And then now we also have Miss Nelly Omina. She's been my mentor in ESSA, one of the key, the founders, yes. She's one of the key founders of this major conference. She was one of the brains behind it. Actually, the idea was dropped to her because she was the chairperson at that time. And she took up the challenge and told us, hey, team, she gathered the team together, and yeah, I got the privilege to be part of that team. And so she has shown me how to organize events. So Nelly, you can come on up and tell us something. Yes, Nelly also works at KPMG. She can tell us maybe a little bit about it and how she ended up in that field. Yes, so thank you so much. Yeah, we get the VIP mic for Nelly. Thank you so much.
Okay, hi everyone. So the chief guest, Mr. Aida Nana. It's such an honor to meet Aida with you. Because if you're a lady in tech, I don't know if you have not had Aida, I don't know if you're in tech. Her name is everywhere.
So if you get a chance, please just interact with her. She can mentor you in technology, but most importantly, she can mentor you in life. So it's just important to interact with her. So, ladies and gentlemen, good afternoon. I don't know if it's evening yet. Yeah, good afternoon.
Good
So,
afternoon.
my name is Nelly Omuna. I'm an alumni of the University of Nairobi. I was studying electrical engineering. I graduated in 2018. Then besides that, I was a SACHA in 2017, 2018. So I succeeded Record Money. Record Money was the SACHA 2016, 2017. So I'm really honored and humbled to be here. It's such an humbling experience because when we started this conference in 2018, Professor Muta gave the idea to us, but honestly, I don't know what's in advice, but for me, I didn't think that 3 years later I would stand here in this conference, we'll be talking to people about how we started the conference. So we just thought at that stage maybe it was just a one-off thing and we'll forget about it. But I'm really just honored and I'm really happy to see that it has carried on and in our place, in our Quincy, in our Bella, have just continued with that studio. So thank you so much, the team that's in this place. I know it's been a COVID year, so it's really you have done the other conferences. So congratulations to you. So I think Grace asked me to talk about my career. I work at KPMG. I'm a technology advisor. So basically what we do, we advise clients, we are consultants, we advise clients. And actually today don't to focus so much on the career. What I want to focus on is maybe just encouraging you to be very much open-minded. So today you're seated here, maybe there are those in here, you graduate in September, is it September? You graduate in September, but just remember that on that same day there are 5,000 other students that are graduating. So you need to be very open-minded about when you go upstairs, because we realize that when you leave university, you don't know. Okay, I'm speaking from a personal experience. When I left the university, I didn't really know which path I wanted to take. Yes, I was studying electrical engineering, but at the end of those 5 years, I still wasn't sure what I really wanted to do. Because in electrical engineering, you have the power, you have the power. And it's okay to not know what you want, but what you need to do is compromise where you are now, just because you don't know what you want to do. So even if you are forced, like engineering was forced down your throat by your parents, just take that and just work as hard as possible. Because whatever you do today, it's your choice and it's going to affect your life. So I just want you to be very open-minded, so that as you go through engineering, you will graduate, but when I was in KPMG, remember 70% of the class used to say, when I graduate, I want to work in Pension, I want to work in Power. But you remember, it's not only the University of Nairobi students graduating, there are 50 other universities that are graduating. Electrical engineers are graduating on the same day as you. And Pension only sets maybe 20 people per year, or even after 5 years. So you need to be very open-minded. And I just want to challenge you to take these opportunities that the ESA team and the CAI team bring to you. So when you're at the conference and you meet someone like Aida, just interact with her. Because for me, I think what was important for me was when you go up there, when you're looking for a job, people will ask you what is your unique selling point. So I have my paper, the got a first class honor. 50 other people got a first class honor. So it's really tough. So you need to have that unique selling point. What differentiates Grace, what differentiates maybe Diana, what differentiates someone else. So such events like this they give you that platform to just have that unique selling point. So in presentation projects, yeah, when you're going to look for a job and you tell someone they presented a project on this and this and this, I didn't win, but at least I presented. Your second question doesn't have to be, I was the chair, doesn't have to be that. It can be a different one. I had a classmate who had this and this problem. I mentored them, and from that mentorship, they were able to pick themselves up and do this and this. So really, it doesn't have to be a big thing. Just identify your unique selling point and just continue developing it, and it will really take you far. For those who interacted with me personally, they know the challenges that I faced at the end of my graduation. So and believe you me, I was able to sell myself even with those specific challenges that I was facing at that time. So maybe I'll share that in another platform, not today. But yeah, so what I just want to encourage you today is for the university take the learning opportunities that you get and really just use them. Use them to just find your unique selling point. You may not know what you want to do today, but don't compromise the journey, because at the end of the day, even if you have the end in mind, people will look at the journey. So your employer will look at, okay, you have your papers, but in between, what are you doing? So people focus so much on the journey. So use that journey that you set point. And then I think just to finalize, because I don't think I can speak. I hadn't prepared to speak today. So just to finalize, maybe I would like to tell you that it's okay. When you graduate from here, it's important to get a mentor in engineering. It's important to get a career mentor, but most importantly, get a life mentor. Because within the university, you are sheltered. Your parents are there, your lecturers are there, your friends are there. Yeah, so it is a pleasure to be here, and my journey, I left here in 2016, and after that, I did not have been the most active person in ESNA. I was in ACES. Does it still exist? Association of Civil Engineering Students. You guys, are you still there? Are you serious? By the time we left, the whole of entry block, we didn't even have Wi-Fi. So we were in access, and we are the first people who introduced Wi-Fi to civil block. Now I've noticed they've extended it to the rest of the department. So I was more active in access, but I was a student in the AK Engineers chapter. Where now, after school, I joined, now I'm a graduate engineer there. And yesterday I was confirmed as the secretary in the council of the AK Engineers. I think I was lucky that because we joined the AK when we were students, and I was among the older people there, but I'm going to talk about the class of 2019. Those girls left school in April, and by June they were all working. So I think that is the one message I would tell all of you. Network, interact with students, interact with people. When you're still a student, interact with professionals. Network as much as you can, because opportunities come first to people who know someone else. So make sure as you're a student, please network, do it a lot. Ben and her team of students, I think most of those girls we had in 2019, they all got employment from most of the engineers in our chapter. So please network. Yes. So after school, I went to SGR, and I was an engineer in roads. Yes, SGR, we have a roads department. It was not so major. We were also not very many. We were very few of us. We were a very small team that was handling roads. And we have been doing it since 2016. We have completed our last road recently, February. Yeah, so now we are done. And after that, I've also been involved in design of roads. So I'm still working for a consultant, APEC, and I am an assistant highway engineer there. It's a pleasure to be here, and I'll tell you, network when you're still students. That is the easiest way to get jobs. And also allow me to talk about one of the most not loved subjects of attachments and internships.
I accept attachments should be paid and internships should be paid. But when you are a student, if you get a good chance to work somewhere, whether or not they give you a stipend, just go and work like just give the best that you can. Because there's the quid pro quo aspect with regards to you will get the skills and people remember. Okay, people remember you and you will realize a lot of us got our first jobs either through networking or through the places where we have gone to attachments. So when you get there, please just give your best. You will be surprised that those are the first places that employ you. I worked as an intern at APEC in their airport project, the runway and the cargo, when I was in 5th year. And that is the next year, after my 5th year, I have been working there and I'm still working there. Got both design and the supervision of schools. So it's a pleasure to be here. I'm so proud of you, all of you. I have loved listening to what you are doing. The presentations are good, so keep up that. And we never had ISEC during our time, so it's very nice to see how much ESA has grown. We didn't have that where the tables didn't have us, and just keep getting better and better. And yes, it's a pleasure to be here. All the best.
All right, thank you so much, Joyce, for the pieces of advice, the encouragement, and the wisdom. Okay, I think she's reiterated Engineer Mungeria's words. Huh? Who remembers what Engineer Mungeria said in a very, very familiar language? Okay, was something like tafuta rafiki hapana tembea peke yako. That's what he said, and that's been kind of the thing that's been going on around. So know the next person, okay? Fantastic. And right about now we've had the singular honor again to have our judges back in the room. So if they will, please, would you come up and have us know who's who? Have us know how that went down. Okay, there we have. All right, let's give him a round of applause for Stephen as he comes up on stage.
Good afternoon, guys. My name is Broko, I'm a software engineer. So it was a pleasure joining my other fellow judges in listening to all the presentations. And just to cut straight to the chase, so everybody, all the 4 judges gave a score between 1 and 5, and then we accumulated all the scores. So the winners, of course, is the team with the highest score. We're told to do the top 3. So that's what we're going to do. So we're going to start from the 3rd place, then 2nd, then 1st place. Okay? Alright. So in 3rd place, we have the team that presented 9. The presentation was on sensor-guided sprinklers. With a score of 16, so they're our 3rd place team.
May the team please come to the stage? Guys, let's give them a round of applause.
Alright, that's Bennett.
You're welcome, Kamina.
Alright, and then in 2nd place, we have the team that presented 7. I think these are the ladies who did the mobile app. So in second place we have Shamba. Okay, I just score 17.6.
Okay, so as we have Dora and Miss Manuve come up, let's give them a round of applause. Fantastic job.
All right. Now for the team or individual or group or something that took first place, you guys want to take a guess? Alright, so the first place team calculated score of 18.75. We have e-bikes.
I was coming here with a cold feet, but she came out with a cold feet, eh?
Alright, maybe some of Catherine.
Alright, so the other team, good job. You did a very beautiful presentation, each one of you. But could only have the people on the podium. We really appreciate your time and your support on this one. I'd like to have the one to thanks, guys.
Hello everyone. Hi. 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 So here we have the gifts. Oh, the judges left out. We have the gifts for the winner and second place and third place. So I would like to announce what. Do you mind if I announce how much you won?
Yes. They don't.
They
don't mind.
Should I?
Yes.
Okay. No, well, no, I'm finance secretary. Second runners-up, they get a check of 15,000 Kenyan shillings. That's the check, and then they give a photo.
Brenda, Mike, Rahma, and the lovely Maria. Okay, let's look pretty, let's look pretty. Round of applause even as they take the shots.
Just the way you are, go to the SHL Isabella Olot
Come see Miss
sign the
Isabella.
check to one person. Yeah, to one baby.
Group photo.
Oh, group. They're not, no, they still are the people. Oh, okay, fine. So, sorry. Second runners-up, sorry. First runners-up, they get a check of drum roll. They get 25,000. To come and present the check. Then afterwards, make sure you get your check signed.
Those are the amazing ladies, Dora Cheriot and Miss Victoria Munuve. Let's give them a round of applause. Let's make sure that the whole team is here. The whole team. I can see our man over here is calling someone from the stage, so if you know that's you, come on. Don't feel shy. Don't feel shy. Fantastic. Alright.
Is the whole team here?
This is the
Yeah.
whole thing here.
Wow, okay. This is a team that that's all is
Greetings once again, and welcome to lesson 4 in the Africa Code Week series entitled Scratch in the Classroom. In this lesson, participants will learn to create
disruption.
So now the winner so the winner gets a check for 40,000 Kenya shillings. The check.
Okay. So we have the E-Pipes by Joseph Budeno. And who's the one over here? Let's put a name behind it.
Actually, we are starting with 4, but because of the lockdown, some of us are going to run back to school. We're going all the way back to digital university.
Big team. Thank you so much for the amazing job. All right. Let's have a check presented to them. Would you do your thing? Fantastic. Look at that. Round of applause. Beautiful.
And now I will hand over to maybe a group photo, all of you.
Okay, time to look pretty together, okay? Fantastic. There goes our top team. We thank you so much, the team that everyone that presented. You did an amazing, amazing job.
So now SIFA will now announce the best essay and maybe say something small, then now after that, now thank you.
Applause, ladies and gentlemen.
Good afternoon, everyone. My name is Sifa Kinoti. I was in charge of the project STEM. So first, I'd like to say congratulations to the winning projects. And second, I'd like to announce the winner for the essay writing competition, which we always had, and which we just concluded. This is the first time that we were running an essay writing competition. And the winner has received a hefty check. And I'd like to call on Engineer Wairimu Muguru from AAK Engineers Chapter to present the check to the winner. The winner is Hold your horses, Jackson Ochieng Mikanon. Jackson Ochieng Mikanon, are you in the audience?
Round of applause to him as he comes out. Round of applause to him, amazing work and time with the ESA.
Congratulations, Jackson. And I'd like to encourage you all in the next IAC, if you don't have a project, submit an essay. If you don't have an essay, submit a project.
Right. Applause, ladies and gentlemen. Fantastic. Coming out of the ESA.
Mentor Ida, kindly join us on the stage. So, as a token of appreciation for our judges, for coming all the way, sparing their time to criticize, to encourage us, because better we not leave this place without some token of appreciation. And I would like Mentor Ida to present the gift hampers to them. Mentor Ida, thank you. So kindly present the gift to the judges. So cameraman,
round of applause, ladies and gentlemen. Amazing job, amazing job. giving us a top team. Right. Round of applause, people. Round of applause. Okay. Round of applause. Let's appreciate that. Okay.
Our panelists have gone home for yesterday, but they will be receiving their gifts. For those that are here, Wamono, Grace, Kani, and Miriam, please come to the stage so we can gift you with our I would like Engineer Mario, please come and
anaitwa Grace ex wangu kama mtu anaitwa Grace ndo dem.
Round of applause, ladies and gentlemen.
Sana mpenda. Wananisumbua maana papo. Piga makofi hata wewe unataka kupiga makofi kisha fans music video awali.
And lastly, we will be awarding our guest of honor that has really graced us with our presence, and we really love to grow and develop with us. We shall be awarding our guest of honor either in just a second.
Okay, so you guys, you've had very great MCs here. We would like to award them before we award Mentor Theinternational. So it became crazy now, this whole we are awarding, so they were on the mic. Now I was wondering how would they then award themselves. So I think I'm the one who's going to just moderate this part. So Michelle, can you put the gifts there for the MCs? And Kaunga Chile. Kaunga, are you here? Kaunga has been an astonishing moderator. If you've been here during the panel discussions, he's been very, very explicit. So he's not here. Okay, who's going to receive the gift for Kaunga Chile? Okay, Sifa Kinoti will receive it. So a round of applause. So we'll start with Grace Kamau. Thank you very much for your work, for your dedication. Thank you very much. You've been awarded by the IEEE Vice Chair, Michelle Murakai. Okay, the next goes to Joseph Madaraka Sugudu. Thank you so much for your dedication. Thank you so much for your dedication and your passion. So now, before we move to the cake cutting ceremony, because I know once you cut this cake, I think people are just going to disappear because people are waiting for this cake, yeah? So Mentor Theinternational, we need to appreciate a round of applause, guys. Thank you very much. So now,
she also loves us men, guys.
Okay, I'm so nervous. Hello guys, how are you? I hope you enjoyed yourselves. So, where I come from, we start our speeches with Bismillah Rahman Rahim. In the name of God, the most gracious, the most merciful. We thank God for having brought us this far. We thank God for what we've accomplished. No event such as this one can be successful without people who dedicate their efforts,
time, and resources to ensure that everything falls into place. I, Rahma, the ESA Secretary General, a part of the media then head, on behalf of the Engineering Students Association and the ISEC Team 2020-2021, extend a hearty vote of thanks to all our speakers, guests, judges, led by our chief guest mentor, Aida Nganga. She's been such an inspiration to us all in these past 2 days. Let's have a round of applause for Mentor Aida Nganga. I'd also like to express our sincere thanks to our sponsors who've largely made this a success. KEBS, Kera, Kiri Consults, Engine, AAK, ASEC, GETSO, Engineer Robert Kinoti of Civil One Consulting Engineers, and lastly, the University of Nairobi Administration that not only came through to provide us with a venue, but also supported us in the entire planning phase. I must say that we've been quite fortunate, or rather blessed, to have a team of self-driven, motivated and dedicated students who are precise to their jobs and results-oriented. That is the ESA executive team, Bella being the chair, Sir Clinton, Fiona Nkapa, Dennis Cheriot, Churchill, Simon Masharia, Eric Raila, and myself. The ISEC 4.0 team, led by the able chair, Quincy Wamono, James Masharia, Fiona Nkapa, Sifa Gaki, Gisheru Murakaru, Hannah Wanjau, and Collins Nasongo being the den heads. All these den heads had strong teams behind them that kept on plowing no matter how tough the road was, to ensure that this part of the 24th and 25th was as clear as it is right now. I cannot fail to recognize the MCs, all our volunteers for their selfless will, ensuring proper coordination and synergy, our media team, who tried their best to provide excellent coverage, and the photographers who captured the moments, and all those who've been part of this elite team. Lastly, ultimately, and most importantly, I'd love to thank all the students, engineering and non-engineering, those from UN and other universities in the nation, those who joined us physically and virtually. You are IESC. You make IESC what it is. We thank you so much, and it's been a good time that we've all had. And thank you, and God bless us all. Shukran.
Now, the people want to thank them making noise. Wonderful, work like magic. Now, I want to express my sincere gratitude to each and every one of you. There is no greater, there is no least. I think I'm just first among equals. And I'm trying to speak your hearts, and I can't even condense them into one. So my words fail. Ready? And the sheer dedication you put, and if any one of you would want to be president, or perhaps myself, this is the team to have. They have really shown that volunteer work is much better than paid work, because it is worth doing. Paid work is only worth it because you have some money after it. This has all been volunteer work, working virtually. We only meet physically for the past 1 month, only. All of it was virtual, and yet we've made strides. I'm those forwards, people. And as I take my bow, I'm not going to be chairman anymore, chairman emeritus. Whatever friendship we forged, let it go on. Perhaps I'm in the presence of ministers and whatnot, and I do not know. Because I can tell this and put this on national TV. This is the kind of leadership we need. And we found it. So there's hope for our country.
Yes.
There's hope for our country. All right. I've noticed the lack of response from the audience. I think it's time. All right. Like I said yesterday, and we've shown it continually through the conference, we are capable of innovation, but most importantly, we are capable of audacity, and we've lived it. Thank you. Usually in celebrations, tunakwanga na ule mama kukata keki.
Auntie.
But I have to sing kata keki. Mama huili. I'm told this cake will be cut by our judges, Mentor Ida. Lady is joining us on stage. Bella and I will hold from the fringes. Our sponsors, AK, your presence, kindly join us on stage. The rest of us will cut by inspection, will follow the line. And then we are going to sing. And I'll be a soloist again. Come on, really? Wait, that's... there's total difference. Alright, our judges on stage. This is the point where we light the cakes. Hold the notes. Hey, but before we start, Yoni cake is yoga.
Joseph Kusana,
Zodoa,
Angeli
Harare,
Dar es Salaam Uncle Sham, Diamond Kinshasa
Kaya Musha, Kamamfwama.
Usiniguse, usinitachi, tusalimiane kwa miguu. Usiniguse, usinitachi, tusalimiane kwa miguu. Onasema usiniguse, usinitachi, salamu iwe kwa miguu. Usiniguse, usinitachi, tusalimiane kwa miguu. Okoza kambali